In today's class, we are going to study permutation, all concepts and all gate PYQs. This is one of the important topics of combinatorics, and if you want to study complete discrete mathematics from me, you can visit Discrete Mathematics course by 𝐀𝐍𝐃𝐑𝐦 sir on 𝐀𝐍𝐃𝐑𝐦 Study Simplified app. The course contains all these chapters: logics, set theory, relation, function, poset lattice, combinatorics part 1, part 2, group theory and graph theory. Do not worry, everything is there: lectures, notes, doubt solving group. You can download and watch, plus all the gate questions are there with tricks and techniques. So everything is covered. Now let us start the lecture. In today's class, we are going to study about permutation. But before going to that topic, let us first understand what is a factorial, because factorial is going to be used in permutation calculation. So as you can see here, the symbol of factorial is exclamation, and operation is n factorial is n into n minus 1 into n minus 2 into n minus 3, so on and so forth. The last term should be 1. For an example, you have to find 4 factorial. Then it is equal to 4, then a number back 3, then a number back 2, and then the number back 1, and stop. Multiply all the numbers, you will get your answer 24. So 4 factorial is 24. Similarly, what is 2 factorial? Start with 2, then a number back, which is 1, stop. Because at the end, once you get 1, you have to stop. So 2 into 1, 2 factorial becomes 2. What is 1 factorial? Start with 1, no need to go back, because 1 is the ending point, and you will get 1 factorial as 1. Now there is one interesting note about factorial. As we have seen, n factorial is equal to n into n minus 1 into n minus 2, so on and so forth up till 1. Now what if I ask you, what is n minus 1 factorial? You will say, sir, it is very simple. If you need n minus 1 factorial, then start with n minus 1, then go a number back from here. That would be n minus 1 minus 1, right? Which can be written as n minus 2. Then go a number back here, then it would be n minus 2 minus 1, which can be written as n minus 3, and so on and so forth. The last player would be 1, right? Can you see this thing is present above? And if yes, I can modify the above expression. So see carefully, therefore I can modify my n factorial expression as, copy this n, but then replace this complete thing with n minus 1 factorial. Why? Because this complete thing is present here, and this thing is nothing but n minus 1 factorial, right? So I'm going to say that this complete stuff is n minus 1 factorial. This is a unique way of representation of n factorial. Also, some student can think in this way, sir, I can rewrite this as n into n minus 1 into n minus 2 factorial also. How come? See here. See, first of all, what you have studied is n factorial is this thing, and I told you, you can replace this box by n minus 1 factorial, because n minus 1 factorial says start with n minus 1, then go a number back, then go a number back up till 1. So this complete thing is n minus 1 factorial, right? Similarly, if I write this 2 player, then I make box from here, then can I say n minus 2, n minus 3, n minus 4, so on and so forth up till 1. This is nothing but n minus 2 factorial expansion, because n minus 2 factorial says start with n minus 2, then go a number back, then go a number back, so on and so forth up till 1. So yes, you can replace this box by n minus 2 factorial. And if you understood the pattern, then you can also say it can be written in this way: n into n minus 1 into n minus 2 into n minus 3 factorial as well. So yes, this was one interesting pattern about the n factorial expansion. Now, there is one doubt. Sir, 1 factorial is 1, 2 factorial is 2, 4 factorial is 24. But what if I ask you 0 factorial? What is the answer? What is 0 factorial? Is it 0? Or is it something else? See, you have studied this expansion. I am going to copy this, and after copying this, let me write it here. I am going to ask you, can you do a substitution? A very simple substitution. Sir, what substitution you want me to make? I just want you to make a substitution of n is equal to 1. If I substitute n is 1 in the above expression, what will happen? 1 factorial is equal to 1 into 1 minus 1 factorial, right? So 1 into this player only, this player says I am 0 factorial. So 1 factorial is 0 factorial. I hope you got the answer now. Therefore 0 factorial is equal to 1 factorial, that is equal to 1, and it is not equal to 0. Okay, so 0 factorial, the answer is what? It is 1. Why the answer is 1? I hope you got the idea now. Okay, it is not 0 but it is 1. Coming to some examples so that you get the confidence in factorials, then we can move forward for the permutation. What is 5 factorial? Pause the video, try by yourself all these questions. Sir, 5 factorial, start with 5, then go a number back till 1 and stop. Then multiply all the numbers, you will get your answer, that is 120. Talking about 7 factorial by 5 factorial, there are two ways to solve. 7, 6, 5, 4, 3, 2, 1, multiply every one. Then 5 factorial can be written as 5, 4, 3, 2, 1, multiply every one, then solve. These two are gone, 4 is gone, 5 is gone, 7 into 6 is the answer. This is one way, a very tedious and time taking approach, but you can use a smart approach. What smart approach? This expansion technique you can use. You can say I am going to reduce my numerator till I get my denominator factorial. Check it out. My denominator factorial is 5 factorial. Numerator was 7 factorial. So first write 7, then go a number back 6, then go a number back 5 and stop, because now they are matching. So 5 factorial. Yes or no? I can write a 7 factorial as 7 into 6 into 5 factorial. I hope you remember this. 7 into 6 into 5 factorial. Yes. If I write in this way, now my calculation is pretty simple. These two are gone. 7 into 6, the answer is 42. Easy. Let us do a good question now. 1 by 8 factorial plus 1 by 9 factorial, that is equal to x by 10 factorial. Can you find the value of x? Okay, so pause the video, try, then look at my solution. What I can do is, I can say this is 1 by 8 factorial. 1 over 9 factorial can be written as 9 into 8 factorial, isn't it so? This 10 factorial can also be written in 8 factorial format. So 10 into 9 into 8 factorial. Why you are doing this? Because now I am going to multiply throughout 8 factorial, here also 8 factorial. If I multiply throughout by 8 factorial, multiply throughout by 8 factorial, then 8 factorials from numerator and denominator, they will vanish, and finally I'm going to get 1 plus 1 by 9, that is equal to x by 90. So if you rearrange and you solve, you will get your answer as x is 100. Very simple, right? Here it would be 10 by 9 and here we have x by 90. So 10 by 9, that is equal to x by 90. 9 ones are 9 tens are, rearrange, x is 100. That is your final answer. Easy. If you have understood this thing, let us dive into the second topic of the day, which is the main topic, permutation. Permutation synonym is arrangement. Whenever you see questions based on arrangement, where order matters, where they are talking about position sensitive, where arranging numbers, arranging letters. So in that scenarios, you have to think of only permutation. Yes, we are going to use permutation. Now, what is a permutation formula? How to use it? Why is it different? Anything special? Okay, so I will take one example and try to elaborate why it is special. Suppose my question is such that I have to arrange A, B, C, D, 4 letters, not with themselves, but only in these 2 positions, okay, where repetition is not allowed. Okay, so without repetition, then tell me the possible words I can generate. 4 letters are there, you have to make sure that you are generating 2 letter words out of it. So how many such 2 letter words I can generate from this ABCD? Pause the video, think, then look at my solution. Let us see solution now. There are multiple ways to solve this question. Let me take the method 1, where students will say I will do manually. Okay, so method 1 is manually, making all the cases to get the answer. I know it's a time taking process, but still I will do it just for fun. So ABCD, 2 letter words from ABCD letters. I can start with A, then I can say B, A, C, A, D. Remember A is not allowed. Why? Because without repetition is going on, right? So only 3 from A, starting with A. Then starting with B, how many? So I can say BA, BC and BD. Similarly, starting with C, CA, CB, CD. Starting with D, I can say DA, DB and DC. So total how many? Total is 12. There can be no more words apart from them. So yes, final answer is 12. Now, if I ask you, is there any other way to solve this kind of question? Then you will say, yes, in the previous class, we have studied the principle of counting, okay? So using the counting logic also, we can solve this question. I have 2 blank, first blank and second blank, and we always go from left to right to avoid any confusions. So tell me for first blank, how many choices we have? A or B or C or D. There are 4 choices to fill this first blank. And since without repetition is going on, the letter which came here cannot come here. So for the next blank, we have 4 minus 1 choices, which means 3 choices. So 4 into 3, the answer is 12. Very fast, isn't it so? Now, if I just modify this, okay? Now see carefully how smart I am. I'm just modifying this thing. 4 into 3, you told 12. What I'm doing is 4 into 3. I want to make sure that I write this in factorial format. So if you want to write this in factorial format, just multiply with 2 into 1 and also divide by 2 into 1 to make sure the overall expression is still 4 into 3, right? But now since it is going to be converted into the factorial format, the numerator would be what? 4 factorial. The denominator is what? 2 factorial, which can be written in this way also. 4 factorial divided by 2 factorial is nothing but 4 minus 2 factorial. Yes or no? If that is the scenario, then this is nothing but your method 3, which is the permutation formula, permutation concept. Okay. Now, I just did the reverse engineering format, but let me give you the official definition. The official definition is the number of permutation, which is nothing but arrangements. So the number of arrangements of n different objects taken r at a time where object do not repeat, then the number of ways comes out to be npr is n factorial by n minus r factorial. Remember, this p is what? Permutation representation, right? N and r are what? N is n different objects, r is taken r at a time. And if you have confusion who is n, who is r, no issue at all. N should be greater than equal to r. N cannot be less than r. So if I ask you here, 4 letters, 2 blanks, who is n, who is r? N is the greater equal to r. So n would be 4, r would be 2. Very simple. Then we are going to say, if you need the arrangements, it would be npr. So 4p2, 4p2 is this thing. How it is this thing? 4p2 would be 4 factorial divided by 4 minus 2 factorial. See, 4 factorial by 4 minus 2 factorial. Understood? This is what your 4p2 npr looks like. So this is the definition. Let me repeat the definition of permutation. I again repeat, this definition is not for all the cases. It is only for that case where you are doing stuffs, arrangements without repetition. Then the number of permutation of n different objects taken r at a time would be npr is n factorial by n minus r factorial. Okay. Now come some properties on NPR formula. Since you know the formula now, I have various substitutions for R. Suppose my R is N, suppose my R is 0, suppose my R is 1. In those scenarios, what would be your NPR value? Think. Sir, if you substitute R as N, then NPR would be NPN, which is equal to n factorial by n minus n factorial, and numerator is n factorial, denominator is n minus n factorial, which is 0 factorial, then 0 factorial is 1, so n factorial by 1 is nothing but n factorial. Always remember, whenever you get npn, like 5p5, answer is straight away what? 5 factorial, n factorial, right? 4p4, answer is 4 factorial. No need to use formula and get the answer, straight away use this result. npn is n factorial. Easy. Similarly, the next result is what if I substitute r is 0? then np0 would be n factorial by n minus 0 factorial, which is n factorial by n factorial, which is equal to obviously 1, right? Now comes what if I substitute r is 1? So if I substitute r is 1, then np1 is equal to n factorial by n minus 1 factorial, which is written in this way, that n minus 1 factorial. Okay, I can say in this way that numerator can be written as n into n minus 1 factorial and denominator is my n minus 1 factorial. So n minus 1 factorial cancel and the answer is n. So always remember, your np1 is straight away n, your np0 is 1, your npn is n factorial. If you have any problem in remembering the result, then in that case you can solve and get the answer. But if you can remember the results, it is pretty fast to get the answer in GATE exam, in competitive exam. Okay. So this was our first type where we talked about without repetition, but sir, we have some types where with repetition also happens. So yes, that is our second scenario. What is the second scenario? Where repetition is going to happen. Okay, so let me copy this question, same question. I'm just changing without repetition to with repetition, and I'm going to ask you, tell me the arrangements possible, the number of letters possible. Okay. So pause the video, try by yourself, then look at my solution. Okay. So let us see the solution. Again, I'm going to follow all the methods, method 1, method 2, so on and so forth. First, we'll do manually. So method 1 is the manual approach. If I do it manually, then tell me what is the answer. Answer would be 16, because now A is also possible. 4-letter and 2-letter word you have to generate from it. So AA is possible. Similarly, we can say AB, AC, AD, and then BA, BB, BC, BD. Then we can say CA, CB, CC, CD. Then we can also say DA, DB, DC, DD. In this way, we have 16 such 2-letter words from ABCD where repetition is allowed. Now, some students will say, sir, why to do manually? You can use the counting principle. Yes, you can use the counting principle to get the answer. First position, and then we have the second position. First position has how many choices? 4 choices. Second position also has 4 choices since repetition is allowed. So 4 into 4, 16 such 2-letter words can be created. Now, method 3. Method 3 says, see carefully, method 3 is nothing but permutation. Now you know very well. So method 3 says, you have first dash and you are saying you have 4 choices. You have second dash, you are saying you have 4 choices, which means this value 4 is repeating how many times? The times you have dashes. So if you have 2 dash, then this is going to repeat 2 times. If you have 3 dash, it is going to repeat 3 times that value. So n dash, n times repetition, right? So 4 the whole power 2, the answer would be 16. And I guess you got a pretty much idea that the definition works in this way, that if you have n objects and r places, like first place, second place, third place, fourth place, dot 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 up till r place, and you want to place n objects in those places where repetition is allowed, like we want to place this letters on this first blank, right? So we had 4 choices. Second blank also we had 4 choices. So if we have n choices, n object means n choices, and we have r blanks, r places, then first blank got n choices, second blank got n choices, third blank got n choices, up till n r blank got n choices. So multiply everyone, n into n into n. How many n's are there? R times, because r blanks we have. So as per the aptitude indices concept, this is nothing but n to the power r, and always remember in permutation n is greater than equal to r. So there should be no confusion. Who is the object, who is the place, who is the choice, who is the blank? There should be no issue. N is always greater, r is always smaller. I hope you got this idea. There is no issue at all. And if there is no issue at all, then just by looking at the question, we have 4 letters and 2 blanks, right? And with repetition scenario is happening, 4 letters, 2 blanks with repetition, then this 4 would be n, this two blanks would be r, so r is 2, n is 4, because n should always be greater than equal to r. Then since repetition is happening, straight away n to the power r, so 4 to the power 2, answer is 16. Understood? So that is when with repetition happens. Easy. Both the formulas are different. As you can see, NPR is n factorial by n minus r factorial without repetition. NPR is n to the power r with repetition. So that is your important note, that NPR has two formulas depending on the scenarios. So it's very important that you read the question and you analyze. By default, this thing happens. Always remember, if nothing is mentioned, then by default they are talking about without repetition. If they are saying repetition is allowed, you can use the letters multiple times. Yes, if that is the scenario, then n to the power r is the answer. Okay, coming to some keynotes that in word problems, what we have to make sure, that permutation is used when arrangement is needed, position matters, order matters. In those scenarios only permutation would be used. Now some students may have a doubt, sir, what are the scenarios where position does not matter, where order does not matter, where arrangement is not needed? Very simple. In handshake, if you are doing handshake, the whole point is to make a greeting, right? To shake hand, not to argue who gave hand first, okay, who gave hand last. So order doesn't matter. Second example would be if you are making a team, then there also order doesn't matter. If Virat Kohli came first, Dhoni came last, still in your team Virat Kohli and Dhoni is there. You have no issue why Dhoni didn't came first, why Virat Kohli came last. You have that no issues, right? The only whole idea is in your team Virat Kohli and Dhoni should be there, right? So in those scenarios position does not matter. I hope you are getting the idea. The second keynote is in word problem, if you have confusion between n and r, the only thing you have to make sure is n should be greater than equal to r. This player sitting at top should be the top value. The player sitting at bottom should be the bottom value. Okay, so n should be top compared to bottom. Okay, and both of them should be greater than equal to 0. Negatives are not allowed. Understood? Even fractions are not allowed. They should be integer only. Now coming to word problems, and you may feel, sir, this question we have seen somewhere. Yes, in the previous classes we have solved this question using counting. Now let us solve this using permutation. Find number of 4-letter words with or without meaning which can be formed from letters R, O, S, E where repetition is not allowed. So you know very well, you made blanks, 4 blanks, first letter got 4 choices, second got 3. Now there is no need for that. We know that in this scenarios 4 letters should be arranged among themselves to create word. Arrangement means permutation. So we are going to use permutation, and I know that permutation is nothing but NPR. I just want to ask which formula, n factorial by n minus r factorial or else n to the power r. Then the question says here without repetition was there, so n factorial by n minus r factorial would be used. Now the second question is who is n, who is r? So if you see carefully, then we have to make 4-letter words and from 4 letters only. So 4 blanks, 4 objects. So yes, n is also 4, r is also 4. So 4 factorial by 4 minus 4 factorial, which is 4 factorial by 0 factorial, which is nothing but 4 factorial. 4 factorial is 4 into 3 into 2 into 1, which is nothing but 24. That is the final answer. Easy. Understood? If understood, now you may say, sir, first method is pretty easy compared to the second. I can agree. So if you are comfortable with method 1, go with that. Sometimes method 2 is useful, so you should know. And method 2, this permutation, is actually a stepping stone for the next topic, combination. So anyhow you have to study this permutation. There is no choice. So example number 2, same kind of question, but the change is repetition is allowed. Then what is the answer? So you know very well, by counting principle you have solved this. 256 is the answer. You can also say that since arrangement question is going on, so permutation would be used, which means NPR is going to be used where repetition is allowed. So with repetition the formula is n to the power r. Who is n, who is r? Here both of them are same, so n equal r equal 4. So 4 to the power 4, the answer is 256. Easy. Now sir, give us questions where n and r are different. Okay, try this question. Again, question which is solved in the previous classes, right? So 10 students compete in swimming race. In how many ways can they occupy first 3 position? Obviously, one student cannot take multiple position. One student can take only one position, right? Then what is the answer? You know how to solve this question by counting principle. In the previous lecture, I have explained. The answer is 720, right? Since you have problem like 3 position and 10 students. So which entity should be dash, which entity should be choice? And I told you the least number entity should be dash. So position should be dashed, first position, second position, third position. Choices you have filled and you got the answer. But now there is no confusion at all. In the permutation, you know that here 10 students compete in swimming race. In how many ways can they occupy first 3 positions? So arrangement matters, right? First position, second. So arrangement matters. So if arrangement matters, then you are going to say order matters. Here order matters, first, second, third. So permutation would be used. And since one student can get one position only, so it is without repetition question. So we are going to use n factorial by n minus r factorial. Now the problem is, what is the value of n? What is the value of r? 3 and 10. 10 is bigger than 3. So 10 would be n and 3 would be r. Very simple. So 10 factorial by 10 minus 3 factorial. So which is 10 factorial by 7 factorial. How to solve it? 10 into 9 into 8 into 7 factorial divided by 7 factorial. So 10 into 9 into 8 in above, you know very well, it is 720. So that is the answer. Easy. Understood how to solve this kind of question? If yes, try this question. This is a new question and last question of the day. Out of 6-digit number, how many 4-digit number can be created? Tell me. So there is method 1 also, there is method 2 also. If you want to go by method 1, you can follow, get the answer. Method 2 is also good to go. So pause the video, try, then look at my solution. So first of all, it's arrangement question. Counting principle can be used. We have to create 4-digit numbers. So first, second, third, fourth, right? Since we have 6-digit numbers and nothing is measured, which means without repetition. So first blank got how many choices? 6, next got 4, next got 5, next got 4, and finally 3. Multiply that and answer is ready. But if you use the permutation concept, then how to deal with this question? First of all, in the exam, you have to identify arrangement of number, because multiple concepts you will study, so you may have doubts what to use, what not to use. Since arrangement of number is going on, which means permutation would be used NPR. Now once that is clear, then the next question is n and r values are what? 6 is greater than 4, so 6 would be n, 4 would be r, right? Since n is greater than equal to r. Now finally we are going to say, since by default things are without repetition, then NPR is equal to n factorial divided by n minus r factorial, which is 6 factorial divided by 2 factorial, which can be said as 6 into 5 into 4 into 3 into 2 factorial divided by 2 factorial, and the answer comes out to be 360. Yes, that is the final answer. I hope you got the idea about the permutation. This is the first part. Do not worry, there are many such cases, many more things to learn on the permutation that would be covered in the second part. But for now, I wanted you to get the glimpse what is a factorial. Then permutation means arrangement. Method 1 also you can use, method 2 also there, method 3. Okay, then method 3 we have this permutation formula. 2 formulas we have to study. These properties are important, right, for the simplification purpose. Keep that in mind. Then you have seen that 2 formulas were this: read the question and then use the formula. If nothing is mentioned, without repetition. If you have confusion, who is n, who is r, n is top, r is bottom, n should be big, r should be small. And whenever position matters, order matters, straight away use NPR, like this question. Okay, this question here also, since first position, second position, third, so first, second, third rank, position matters, order matters. Okay, now that's it for today. Meet in the next video. In previous lecture, we have studied about permutation. where we have seen two types. First type was permutation without repetition. Second type was permutation with repetition. Now in today's class, we are going to study new concepts of permutation, basically two more new type. Okay, so welcome to part 2 of permutation, and let us start the lecture with the very first question. I have three letters MAD. You have to find the number of ways to arrange these letters among themselves. Pause the video, try by yourself, then look at my solution. Very simple. I know you will say, sir, no need of any concept. I can simply arrange in this way: MAD or else MDA. Also, A can take the first position, so MD, or else you can see DM. D can also take the first position, so DAM, or you may say DMA, right? So only we have 6 possible ways to arrange these letters among themselves, right? Some student will say, why to do all these things? It's time consuming. Just make dashes, because 3 letters to arrange among themselves. So 3 letters, 3 dash. Now this is without repetition scenario. So first blank got how many choices? Yes, definitely it got 3 choices. Next blank will get a choice less, which means 3 minus 1, 2. And finally, last blank would be 1. So 3 into 2 into 1, the answer is 6, as you got in the previous. Now some students will say, sir, why to do all these things? You have studied permutation. This is arrangement. So permutation means NPR. You have to ask here with or without. So it is a without repetition. So we know it is n factorial by n minus r factorial, right? And what is the value of n here? 3 letters and 3 dashes, right? So basically it is 3p3, and whenever you have npn, you know it very well, it is n factorial, so 3 factorial, or else you can substitute here 3 factorial by 3 minus 3 factorial, which is again 3 factorial only, which comes out to be 6. Now you have studied this in the previous lecture, but what if I try to modify these 3 letters with this letter AAB? Now can you find the number of ways to arrange these letters among themselves? Now some students are like, sir, now I am not going to use method 1, method 2, straight away I am going to use method 3, that I know arrangement among themselves. This is NPR, it is a without repetition. So we can see 3 letters and 3 blanks. So 3p3, it is a 3 factorial 6. Very good. That is the wrong answer. That is the wrong answer. Why? Let us investigate by manual method first, so that you get the idea. Okay, so solution starting with the manual way, method 1. If I arrange like AAB, then I can shift the positions, right, of B. So it can be ABA, and then it can also be BAA. Other positions not allowed, right? Like you cannot say this is A1, A2 and switch this position among themselves. That is not correct, right? So these are the only possible ways to arrange these letters among themselves, which means the answer should be what? 3 ways only. And by doing NPR, what you got? 6 ways, which was incorrect. You know why you got 6 ways? That is the very good question. Why you got 6 ways and not 3 ways while solving this question? Because what you did here is, by using that NPR without repetition, what you did here is, you basically consider this AA as A1 and A2, and you also arranged this A's among themselves, which was unnecessary, which was redundant, but you did that unnecessary stuff, and therefore you got 6 ways, that unnecessary extra answer. So how to overcome this unnecessary stuff and arrive at the correct answer? Very good question. So here you have to say that if I arrange these letters among themselves, it is 3 factorial, yes or no? It is either you can say 3p3 or you can say 3 factorial by counting principle. So yes, it is 3 factorial. But while doing this, what happened here? While doing this, what happened here? You know it very well that I rearranged this A's by taking it as A1, A2, and I told that A2 can come first, A1 can come later, so on and so forth. So that was unnecessary. I will write here unnecessary arrangements were made. So how to overcome that unnecessary arrangement? By very simple trick, just divide this by 2 factorial. Sir, why 2 factorial only, not 3 factorial, 4 factorial, anything else? There is a reason behind it. So very important reason. What is the reason behind it? Since this letter A is repeated how many times? It comes 1 and 2 times, right? So this letter A is coming 2 times. Therefore, we are doing 2 factorial. Sir, what if this letter A comes n times? Then n factorial we have to divide. Understood? This is your type 3. So what is type 3 in permutation? Number of permutation of n objects where p objects are of same kind and rest all are different. Like you can see here that B was a different kind but A was repeating. So if you have p objects of same kind, which means of repetition, and the rest are different, in that case you will say the number of permutation of this n object is, first they will be arranged among themselves n factorial. Unnecessary stuff you have to divide with p factorial and you will get your answer. Like here 3 factorial by 2 factorial is nothing but 3 into 2 factorial by 2 factorial, which is 3, and this is what your answer is. Understood? So very important, type 3, you have to make a note. Whenever you have repetition of letters and they are asking, whenever you have repetition of letters and they are asking you about arrangement of the n objects, then you simply do first n object arrangement by saying n factorial, then divide with whom? The player who is getting repeated. So I hope you got the idea, and let me take this notations out from this slide. And if you understood this thing, I have a question for you again. Find the number of permutations of letters of word Allahabad. Pause the video, try by yourself, then look at my solution. Now you know very well, sir, this is the arrangement question, and recently we have studied that if repetition happens, right? If repetition happens, so first arrange letters among themselves, then divide with the repetition part, right? So here I am going to say Allahabad have how many letters? 1, 2, 3, 4, 5, 6, 7, 8, 9. It has 9 letters. So they can be arranged among themselves in 9 factorial ways, but we can see repetition, right? A is repeated how many times? 1, 2, 3, 4. So I will divide by 4 factorial and I got the final answer, right? That is incorrect. Because A letter is repeated and we have L letter also in repetition. Okay, in previous type P object were only of same kind, right? Which means only one letter was getting repeated, rest were different. But here 2 letters are getting repeated. So what to do? A is getting repeated, we did 4 factorial, but L is also getting repeated. So in that case you have to use the same concept. L is repeating how many times? 2 times, so 2 factorial in the division. That is your final answer if you solve it out. So 7560 you will get. Understood? So let me write it here. We did this for L repetition, we did this for A repetition. Okay, so that is your next type, type 4 in permutation. Number of permutation of n objects where p1 object are of one kind, p2 object are of second kind, p3 are of third kind, so on and so forth, and rest if any are different kind. Then in that case n objects are arranged in n factorial ways, then p1 objects are of same kind. So let me say that there is one letter which is repeating p1 times, so divide by p1 factorial. There is other letter which is of p2 kind, which means there is a letter L, let us say, repeating p2 times, then p2 factorial, then p3 factorial, dot 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 up till pk factorial. Understood? So this is what you have to do, and these are the only 2 types which you have to study in this class, but varieties of questions can be made out of this concept. So each and every variety I'm going to explain so that you get mastery in this topic. Okay, so let us go to the examples now. First example in front of the screen: 𝐸𝐷𝐸𝐶𝐴TION. These letters you have to arrange among themselves such that vowels are always together. So pause the video, think, then look at my solution. Now this is something new, right? Because this kind of concept we have not seen earlier. But it's very easy. You have to analyze first and then you have to get the answer. So first thing I'm analyzing is vowels are together. What is a vowel? Vowel means A, E, I, O, U. These are vowel. The letter apart from vowels are known as consonants, right? So now, if I see this letter education, right? If I see this word education, it has many letters where E, U, A, I, O. These are vowel, and D, C, T, N are consonants, right? So the constraint is only one thing, vowels should be together. What about the consonant? They can be together, they cannot be together, no issue, right? So first I will write the consonant, which were D, C, T, N, and then I am going to write the vowels, which are E, U, A, I, O, right? Please make a note, vowels should be together, so I am making a box here because they should be together. And now do the arrangement. How to do the arrangement? Very simple. This box I will consider one player. This is the second player. This is the third player. This is fourth player. This is fifth player. So 5 players can be arranged among themselves in 5 factorial ways, right? So they are arranged in 5 factorial ways, and do not forget this letters inside the box can also be arranged, right? So the players are arranged in 5 factorial ways, and which means multiplication, and this box has how many letters? 1, 2, 3, 4, 5. This 5 letters inside the box can be arranged among themselves in 5 factorial ways. So this is your final answer. Understood? If understood, then try this question by yourself. We have preparation word which has so many letters. Here same concept, vowel should be together. Tell me what is the answer. Now I know a lot of students will make mistake here, but I also know you know the concept right now. First of all, you will mark the vowels E, A, I, O and A also here. Recheck, no vowels are missed. Yes. Then consonants are P, R, P, R, T, N. So first of all, what you are going to do is you are going to write the consonants P, R, P, R, T, N. Then you are going to write the vowels, which is E, A, I, O. Constraint was vowels should be together. So how many players are there? One player. This is one player, right? This box is completely, you have to consider one player, because if you do not consider that as a one player and you try to arrange, then vowels can get separated, okay? But your constraint is vowels should not be separated, they should always be together. Therefore, I'm making it as a box so that you are always together and considering it as one player. Then this is second, third, fourth, fifth, sixth, seventh. So 7 players can be arranged among themselves in how many ways? 7 factorial ways. And this letters inside the box can be arranged among themselves in 3 to 5. So 5 factorial ways, right? So that is the wrong answer. Sir, why this is wrong answer? Do you remember our type 4? If a letter is getting repeated P1 times, then divide by P1 factorial. If a letter is repeated P2 times, then divide by P2 factorial. Have you checked that here? In the previous, there was no repetition, right? E, D, U, C, A, T, I, O, and every letter were distinct. So that type 3, type 4 concept was not used here. But here we can see that P is repeated 2 times, R is repeated 2 times, A is repeated 2 times. So have you divided that repetition part? So I'm going to divide now. P is repeated 2 times. So let me change the color, okay? You can see that P is repeated 2 times. So divide by 2 factorial. R is repeated 2 times. So divide by 2 factorial, and A is also repeated 2 times, so divide by 2 factorial. This is your final answer. This is perfectly okay, no mistakes here. Getting the idea? If yes, now try something new. Consonants are always together. Solve this question. Now I know very well you are getting familiar with this topic. What you are going to do is, first of all, you are going to say S is a consonant. This is also a consonant, T and R, okay? I and E are vowels. Others were consonants. So vowels you are going to write first, because they can come together, they do not come together, no issue, okay? But consonant should be always together here. So who are the consonants? S, S, T, R. They should always be together, so make a box. Ask yourself how many players? 1, 2, 3. Three players can be arranged among themselves in 3 factorial ways, and the letters inside this box can be arranged among themselves in 4 factorial ways. And you have to make sure that if there is a repetition, you divide that. So we can see S is repeated 2 times, so divide by 2 factorial. That is your correct answer. Getting the idea? So let us do something like level up now. We have machine, you have to arrange these letters among themselves such that vowels are never together. Vowels are never together. How to do that, sir? It seems very tough. So whenever you feel like some constraints are very tough, think of the complement logic. What is complement? Requirement is total minus unwanted. Do you remember the previous lectures? If yes, then you are going to say here that the concept is requirement is total minus unwanted. So here I am going to say total is 1, 2, 3, 4, 5, 6, 7. 7 letters can be arranged themselves in 7 factorial ways, minus unwanted is nothing but, since your wanted is vowels are never together, so unwanted would be vowels. Okay, so here vowels are never together is your requirement, so opposite of that is vowels are together. Vowels are together. So if that is the scenario, you know how to solve if vowels are together. So you can make it here that M is consonant, C is consonant, H is consonant, N is consonant, vowels are A, I, E, which should be together, right? So for here I am solving, right? So you can see that this letters 1, 2, 3, 4, 5. This 5 players can be arranged among themselves in 5 factorial ways, and the letters inside the box can be arranged in 3 factorial ways. There is no need for division because no repetition of letter is happening. So that is your final answer. Understood? So always remember that if contra question comes, what is contra question where directly you cannot solve, then complement logic is the best. This logic, requirement is total minus unwanted, that is best when the contra question comes. Okay, going to the next question. You can do this because you know this is a contra question. Vowels are never together. We have word sister. So pause the video, try by yourself, then look at my solution. I guess you are getting a fun now with this kind of questions, yes or no? So what is your answer? It is total minus vowels are together. Okay, how to solve? So total is 1, 2, 3, 4, 5, 6. 6 letters can be arranged among themselves in 6 factorial ways, but S is repeated 2 times, so divide by 2 factorial. Minus vowels are together, so let me make it here that S, S, T, R are consonant, I, E is vowel. So 1, 2, 3, 4, 5. 5 players can be arranged among themselves in 5 factorial ways, and 2 letters can be arranged among themselves in 2 factorial ways. Divide by the repetition. S is repeated 2 times. This is your final answer. Understood? If understood, let us go to the next question. Vowels only occupy odd position. Now this is something new, right? Because here arrangement should be done with this constraint. Vowels only occupy odd position. So this is your word. So how many words are there? 1, 2, 3, 4, 5, 6. 6 words. So we will have 6 places, right? Let me write solution with different color. We'll have 6 places. First place, second place, third place, fourth place, fifth place. Isn't it my writing going like a mountain way upwards? Let me write it flat. 1, 2, 3, 4, 5, 6, right? So 6 positions are there. In that 6 position, you have to fill vowels at the odd positions. So odd positions are only 3, 1, 3 and 5. These are the odd positions, right? So in this places only vowel should come, which is E, A, I. So tell me, 3 positions, 3 letters, how many ways you can arrange? 3 factorial ways you can arrange, isn't it so? So 3 factorial ways. Why 3 factorial? Because A, E, I has 3 places. So 3 factorial. And the players which are not vowels, that is D, T, L. And again for them we have 3 places. So for DTL, they can be arranged in 3 factorial ways. This is for DTL. So final answer is 3 factorial into 3 factorial, which comes out to be 36. Easy. Sir, this is very easy, but we need a level up question. Okay, so vowels only occupy odd position, a level up question for you. Sir, why this is a level up? Try, pause the video, try by yourself, then look at my solution. I hope you are getting the problem now. Sir, machine has 1, 2, 3, 4, 5, 6, 7. 7 places. So, first, second, third, fourth, fifth, sixth, seventh, right? So 7 places and odd position 1, 3, 5, 7. These are the odd positions, right? And 4 odd position, but the problem is there are no 4 vowels here. How many vowels are there? 1, 2, 3. So how to arrange now? 4 places, 3 vowels, how to arrange? If you know the permutation formula, then you have no issue. Who is greater? Sir, here we have blanks 4 and letters 3. So 4 is greater than 3, which means N is 4 and R is 3. So just use NPR where without repetition is going on. So 4P3, you will get your answer of arrangement, right? But for those students who are unable to understand this thing, if you need visualization that how this arrangement can be made, so for them I will make cases so that you get the clarity. Okay. Case number 1. See, we have 1, 3, 5, 7, this odd positions, and we have 3 vowels. So how to arrange these 3 vowels in these places? Obviously, 1 seat would be vacant. Let us fix the vacant. Let me first take a scenario where position 1 is vacant. Okay, so that is a blank. Position 1. If position 1 is blank, 3 position is filled, and it got how many choices? 3 choices, right? Then 5th position, it can be filled. Okay, how many choices it get? 2 choices, since without repetition. So 1 player seated here, so a player less will be seated, so 2 choices, right? Then lastly, for 7th position, we have only 1 choice left. So 3 into 2 into 1, there are 3 factorials, or you can say 6 ways to arrange vowels where first position is empty, right? Similarly, second position can be empty, third position can be empty, so on and so forth. If second position is empty, we got first and this choice, this blanks, right? So for this blank, we got 3 letter choice. For this blank, we got 2 letter choice. For last blank, we got 1, so 3 factorial again. And I hope you understood. This is how we are going to create 4 cases, because now third position can be kept blank, then we can make 4th position kept blank, right? So same thing, 3 vowel choices, 2 choices, 1 choices, 3 factorial, 3 choices, 2 choices, 1 choices, 3 factorial. So finally, how many? 4 into 3 factorial, which is nothing but what it is, 4 factorial, right? So if you add every player, this is what you are going to get, 4 times 3 factorial, which is nothing but 4 factorial, and 4 factorial is 4p3. That's what I said. You got 4 blanks and 3 letters. So who is N, who is R? N is greater than equal to R, so N would be 4, R would be 3, and the arrangement is 4p3 without repetition. Straight away you can say that. Okay, so I hope you are getting the idea how to solve this question fast if you want to. So 4p3, this is for the vowels, and for the rest part, how to solve? So M, C, H, N, we have 4 letters, and you might be thinking, oh, but we have only 3 blanks. So 4 letters, 3 blanks, they can be arranged in 4p3. Now that is incorrect. Why? While arranging this thing, while arranging vowels, 1 position was left empty. That position will be taken by this consonants. Okay, so it won't have 3 blanks. It will have 4 blanks only. That 4th blank is from where? From here. That you can see vacant, vacant, vacant. That vacant position will be taken by the consonant, right? So M, C, H, N have 4 blanks only. So 4 blanks, 4 letters, they can be arranged among themselves in how many ways? 4 factorial ways. Understood? And not the 4p3 kind of format, right? Anyhow, you get 4p3 as 4 factorial only, but conceptually you should know that this 𝐀𝐍𝐃𝐑 do not have the 3 blanks, but it get 4 blank to get placed. Okay, so conceptually you should be very much clear. And finally you are going to say 4p3 is 4 factorial by 4 minus 3 factorial, which is 4 factorial again. So this is your final answer. Let me write it here just for the clarity, that why it is 4p3. It is 4p3 because 4 blanks and 3 letters. So N is 4, R is 3, and because it is arrangement, therefore NPR. And why this is 4 factorial? Why not 4p3? Because 𝐀𝐍𝐃𝐑 gets 4 places. From where it get the 4th place? From this blank it get the 4th place. Otherwise 3E1 position you know very well, right? Okay, so that's it for today. No, because we have more things to study, right? That's it for that previous question. Now you have a new question. Vowels only occupy odd position, and you have pounding as the word. Pause the video and think, because now you know the concept. You can solve this question very well. Sir, pounding, so 1, 2, 3, 4, 5, 6, 7, 8. 8 position it got. So 1, 2, 3, 4, 5, 6, 7, 8. 8 position it got, right? So 8 position it got, and vowels only occupy odd position. So first, third, fifth, 7th. So we have 4 odd position. How many vowels are there? 1, A, E, I, O, U. 2, 3. Only 3 vowels, and 4 position. How to arrange them? Now you know very well how to arrange them conceptually also and formula wise also. 4p3, so no issue at all. And the rest would be arranged in the rest positions. So we know that the rest letters are, consonants are 1, 2, 3, 4, 5. So 5 letters will get 5 places, no worry. But if you see here 1, 2, 3, 4, 5 letters have 4 position only. 4 position, but 1 vacant would be there now from here. So it will consider that place as well. Therefore, now I am going to say that the rest letters got the 1, 2, 3, 4, 5. 5 letters got the 5 position for arrangement, and it can be arranged in 5 factorial ways. So is it the final answer? No, it is not the final answer. Why? I just wrote 4p3 into 5 factorial. Sir, I should simplify this, right? So 4 factorial into 5 factorial. Is it my final answer? No. Why you are saying no? I am doing correctly only. Then also you are saying no, because you forgot the lecture 4th concept. If there is a repetition, then you have to divide. So what is that type here which is going to be used? Type 3. You can see here that n is repeated only, and that to 2 times. So divide by 2 factorial I am going to do. Okay, that was your type 3. So finally I am going to say this is nothing but 4 factorial into 5 factorial divided by 2 factorial. You can simplify it by yourself and you can get the answer. Okay, so this is how conceptually you have to be aware. In the previous there was no repetition. M, A, C, H, I, N, E, every word were different. Okay, so no problem. But here repetition was there, so you have to be cautious. Understood? Got the idea? If got the idea, let me check now. One question, but varieties of sub question from it. See, I have independence as the word which has so many letters. Find the number of arrangements. First, words start with P. Pause the video, think, solve, then look at my solution. Words start with P, so P position is fixed, but the other positions are vacant. If I count it out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 position would be vacant, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters, 11 position can be arranged in 11 factorial ways, but that is not the final answer, since repetition I can see. And many repetition I can see, so type 4 concept we have to use. Is I repeated? No. Is n repeated? Yes. How many times? 1, 2, 3. So n is repeated 3 times. This is for n letter, right? D repeated 1, 2, 2 times. 2 factorial. This is for D. And E is repeated 1, 2, 3, 4. 4 times. this is for E. That's all. Other letters, P is only one time, N is done, C is only one time, D is done. Okay, so I guess every letter is done. This is your final answer. If you solve it out, the answer comes out to be 138600. Okay, now sub question 2. All vowels always comes together. Now you know very well how to deal with this kind of question. Let me see. Pause the video, try, then look at my solution. Okay, vowels are always together. If I see the vowels I, E, 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 that's all. Others are consonant. So N, D, P, N, D, N, C. These are the consonants. Vowels inside the box I, E, 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 E. Okay. So now, first player, second, third, fourth, fifth, sixth, seventh, eighth. 8 players can be arranged among themselves in 8 factorial ways, and these letters inside the box can be arranged in 5 factorial ways divided by the repetitions. Repetitions we know very well that the repetitions are from here. I can copy 3 to 4. Okay, because we have solved earlier, I won't use my brain much. 3 to 4. That's all. If you solve it out, 16800, that would be your final answer. Easy, understood. Then sub question 3. Vowels never come together. Sir, we know very well this is contra kind of thing. So the answer is total arrangement minus. Total arrangement minus vowels comes together. Okay, so total arrangement, since we know from here that the dashes were 11, if we consider P also, it would be 12. So independents have 12 letters which can be arranged among themselves in 12 factorial ways. And do not forget about the repetitions, which were 4 factorial, 2 factorial, 3 factorial, right? If I talk about now vowels comes together, then what would be the answer? Vowels comes together. That we haven't solved right for now. Vowels come together. Have you solved? Sir, we have solved here. Vowels always come together. So 16800. Just do the copy paste. Just do the copy paste. Simplify it out. The answer comes out to be how much? The answer comes out to be 1646400. Okay. This you can solve this by yourself. The calculation part, but the conceptual part I will tell you. Coming to the sub question 4, words begin with I and end in P. How many such words can be made from independence? Okay, so you know that 12 letters are there in independence. First position is fixed, last position is fixed. So how many positions are left? 10. Okay, so 10 positions. And how many letters? 10 letters. So in how many ways they can be arranged? In 10 factorial ways. But do not forget about the repetitions, which were since I and P are distinct, so please make a note. Then I and P are distinct, no issue with that. The N, D's and E's are in the repetition, so definitely you have to divide them. N, D's and P's, N, D's and E's. So 3 factorial, 2 factorial, 4 factorial. If you simplify this out, so 12,600 such words can be created. And that's it for today. I hope you enjoyed the class. You got the mastery in the topic of permutation part 2, which had 2 new type. This was type 3 and this was type 4. Actually type 3 is a subset of type 4 only. So if you remember type 4, type 3 is by default by hearted. So in permutation up till now you have seen the 4 concept: without repetition, with repetition, then one letter is repeated and multiple letters are repeated. Okay, so I would suggest first, second and fourth should be strong. If that is strong, this third can be eliminated because third is a subset of fourth only, right? So if you remember this thing, then this is the parent and this is the child concept of it. Okay, so yes, that's it, and I hope you understood each and every type and what were the traps. You have to always keep in mind about the repetition of the letters. Okay, you have to always keep in mind, if you have issue 4 places 3 letters, then 4P3, then NPR, right? So that is the concept. Otherwise cases, scenarios are there to get the answer. Okay, and yes, everything was taught in a very precise, crystal clear format. I hope you enjoyed the class. That's it for today. In today's class, we are going to study 2 new topics on permutation. First topic is linear arrangement and second topic is circular arrangement. By the way, this is finale on permutation. So welcome to permutation part 3 lecture, and let us start the lecture with the very first topic, linear arrangement. See, up till now, whatever you have studied by default, it was linear arrangement only. For an example, arrange numbers among themselves, arrange letters among themselves. So this was linear arrangement. And whenever you see keywords like make person sit in a row, or else on a bench, or else in a line, or on a desk, so these are nothing but examples or synonyms for linear arrangement, which means nothing new here. You have already studied how to make letters arrange among themselves and so on and so forth using the counting principle or the formulas. Then what's new in today's class? I will make boys and girls sit in a row with different constraints, and then can you successfully overcome that obstacles? There will be different constraints, okay? Like this question. Let me check whether you can solve this question or not. Arrange 5 boys and 4 girls in a row such that no 2 boys are together. So nothing new. You know already how to arrange person. So pause the video, try by yourself, then look at my solution. First of all, whenever I read this arrangement question, first I check, are you making them sit in a row or on a table? Since it is in a row, therefore linear arrangement. Second, I see boys and girls are present. Constraints are given on whom? No 2 boys are together. So constraints are on boys. Therefore, first I will make girls sit. Sir, why you are doing that? Why girls sit? Because you only think no 2 boys are together. When it can happen like this, boy, girl, boy, girl, boy, girl, in this way, right? Or else girl, boy, girl, boy, girl, boy, in this way. Only 2 possible way, boy first, girl next, or else girl first, boy next. Only 2 possible way, which means, in short, which means if girl is seated here, then before that and after that there shouldn't be any girl. There should only be boy. Okay, here also you can check. If I have a girl seated here, before that and after that, no girl, only boy. If I take the extreme, in the extreme, if there is a blank here, if you want to make him sit boy, then that's okay. If you have less number of boys, you don't want to make him sit here, no problem. But before and after, boys only, no girls. Then only you can say no 2 boys are together. Understood? So when I say make girls sit first, so my pattern would be girl seated, before that dash, after that dash is left for the boys, okay? Then comes girl, then dash, then come girl, then dash, girl, dash. Don't do girl dash because we have only 4 girls and 4 girls are seated, right? So now see, since 4 girls are not identical in our real world, 4 girls are never identical, every girl is unique. So basically 4 girls are like G1, G2, G3, G4. So G1, G2, G3, G4, 4 girls, let me write it like this, 4 girls, and we have 4 positions for girls, right? And we have 4 positions for the girls. Therefore, tell me the number of ways to arrange the girls. It would be 4p4, or simply you can say 4 factorial ways, right? This was all about the girls. Now let us talk about the boys. For the boys, we can see how many vacancies? 1, 2, 3, 4, 5. 5 vacancy and 5 boys. Okay, no problem. We have 5 boys and 5 position is there. Therefore, the number of ways to arrange boys would be 5 factorial. And the final answer would be what? Arrange girls and boys. So 4 factorial into 5 factorial. And means multiplication. So 4 factorial into 5 factorial. That is your final answer. Easy, understood how to solve this kind of question. Basically, different patterns you have to generate, like this pattern. That patterns are nothing but as per the constraints, right? So you can see no 2 boys are together. This is how the pattern looks like. If you understood this thing, let us go to the next question. I will modify the questions. Arrange 5 boys and 4 girls in a row such that now no 2 girls are together. Previously, no 2 boys were together. Now, no 2 girls are together. So since you know the technique, pause the video, try, then look at my solution. So since girls are on the constraints, now I will make boys sit first. Same technique. boy here, before and after no boy should be there. These are the positions for the girls. Then comes boy dash, boy dash, boy dash, boy dash. That's all, because we have 5 boys. So we have seen that boy vacancy 1 2 3 4 5. So we have in total, let me write it here, we have 5 positions for boys and we have 5 boys. So tell me the number of ways to make them sit. 5 factorial ways, right? And what about the girls? If I check about the girls, then we have 1 2 3 4 5 6. We have 6 vacancies and only 4 girls, right? We have 6 positions and only 4 girls. So how many ways? Is it 4p6 or 6p4? Obviously it would be 6p4. So 6p4 you can say it as 6 factorial by 6 minus 4 factorial, which is 6 factorial by 2 factorial, right? And what is the final answer? Final answer would be boys and girls should be seated, then only this thing would be matched, that in the sitting no 2 girls are together. Therefore answer is 5 factorial into 6 factorial by 2 factorial. Understood? Very simple. Also you can visualize that why 6p4 is allowed, why it is not invalid, right? You can also visualize that suppose girls are seated 1 2 3 4. Is this the scenario where I can say that yes, no 2 girls are together? You may argue, but sir, boys came together. Since no one is sitting here, so 2 boys came together. Agreed that 2 boys came together. I have no issue with that. My constraint is only no 2 girls are together. 2 girls should never be together. So this pattern makes sure that no 2 girls are together. I am not considering here that no 2 boys are together. That is very much important that you have that observation. So that observation I am writing out here. So in the first question, we have seen that arrange 5 boys and 4 girls in a row such that no 2 boys are together. So this was the pattern where no 2 boys are together. But surprisingly, this is the scenario for also no boys and no girls together. How come, sir? Okay, so make this 5 boys sit in this pattern. So boy 1 2 3 4 5, right? So can I say here no 2 boys are together? That is satisfied, but also no 2 girls are together, right? So that happened by luck, by chance, not by forcefulness or I wanted to. Just by luck it happened that no 2 boys and also no 2 girls are together here. Okay, if you see the second example, that luck didn't work, because when I arranged 5 boys and 4 girls in this criteria, this was the pattern. Okay, let me take the example also. Let me sit that let me make the 4 girls sit in this pattern. So girl 1 2 3 4, and you can see now when I made them sit, these 2 blanks are not filled, which means 2 boys came together. So this kind of thing is not going to work. So in the second example, we have to say that only 2 girls didn't come together, right? Boys can come here. Okay, boys can come, and we have no issue since the constraint were only on the girls. So that was the observation I wanted to make sure. Now coming to the next example, question number 3, arrange 5 boys and 4 girls in a row such that alternate boys and girls. Pause the video, try, then look at my solution. Easy, you can handpick and make the scenarios, like starting with the boy and then girl, BG, BG, BG. How many boys? 5 boys and 4 girls. 4 girls are done, so 1 more boy. And that's how 5 boys and 4 girls are seated such that they are alternate boys and girls, right? So this is the right scenario where I made sure that we are starting with boy. Some students are like, why not ladies first? Okay, so you can start with girl, then boy, girl, boy, girl, boy, girl, boy, and 4 girls are done, 4 boys are done, but we have 5 boys. Now what to do? You will say, sir, boy here, that is not allowed. Then you will say, oh sir, then boy here. Then the above scenario is same. Isn't it so? So boy here is the only way to make it new, but that is not allowed. So I have to say that starting with girl sequence is not fulfilling our criteria, and the above case is the only case which fulfill this criteria. Therefore my final answer is, if I take this scenario, my final answer is 1, 2, 3, 4, 5. 5 position for boys and 5 boys are there. They are seated in how many ways? 5 factorial ways. And then 4 position for girls and we have 4 girls. They are seated in how many ways? 4 factorial ways. That is the final answer. Remember, this was for boys sitting and this was for the girl sitting. This is how I have solved. Understood? Now let me modify this little bit. Just instead of 4 girls, I am making 5 girls. Now tell me what is the answer. If you are thinking that, oh, the answer would be 5 factorial into 5 factorial, you are doing a mistake. That is not the answer. Then sir, what is the answer? The answer is, I have told you, whenever the constraints are there, you have to analyze the constraints and then only comment on the answer. Okay. So starting with boy, then we have girl, BG, BG, BG and BG, right? So 5 pairs would be there because 5 boys and 5 girls. You can see 1, 2, 3, 4, 5. 5 boys, 5 girls. They are alternate. Okay. So this is a right sequence where I should say this is the sequence where we are starting with boy first. Now the same thing you can start with the girl first. So GB, 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 GB. So this is nothing but again right sequence because alternate boys and girls but starting with G. So a unique sequence, right? Starting with G. In arrangement, position matters. So therefore G starts, B start, that position matters. So we have 2 such cases. If we have 2 such cases, then you have to make sure that for the first case, you know the answer very well, that 5 boys, 5 factorial ways arrangement, 5 girls, 5 factorial way arrangement. Second case, so case 1 plus case 2. So case 2, 5 girls, 5 factorial ways and 5 boys, 5 factorial ways. So that is your final answer, 2 times 5 factorial the whole square. Okay, I am not simplifying to the final answer. I am just giving you the ideas whenever the constraint come, how to deal with the arrangement. Understanding, getting the scenarios, getting the idea. So I will solve varieties of question, do not worry. So question number 5 in front of the screen. Arrange 4 boys and 4 girls in a row such that no 2 girls come together. 4 boys and 4 girls in a row such that no 2 girls come together. Okay, so boy should be seated first, a blank before, after, then B dash, B dash, B dash, right? 4 boys. So in this way, if I make them sit, then no 2 girls can come together, right? So I can say here that boys sitting would be 4 factorial. Okay, so this is for boys. And for the girls, we have 1, 2, 3, 4, 5. 5 vacancy, but only 4 girls. 5 vacancy, 4 girls, so 5p4. In this way, this girls would be seated. What is 5p4? 5 factorial by 5 minus 4 factorial, which is nothing but 5 factorial only. So 4 factorial into 5 factorial is my answer. Understanding, if understanding, try this question. Okay. So I hope you are getting the idea. These questions are not that tough, but it just make your brain more analytical, right? So 4 boys, 5 girls in a row such that no 2 boys come together. So make the girls sit first. 1 girl, 2nd girl, 3rd girl, 4th girl, 5th girl. This is the pattern where no 2 boys can come together. So arrangement for the girls, 5 girls, 5 factorial ways, but for the boys we have 1, 2, 3, 4, 5, 6. 6 vacancies but only 4 boys. So 6 vacancy, 4 boys, 6p4 ways, right? So let me write it here. This is for girls and this is for boys. If you want to simplify, 5 factorial into 6 factorial by 6 minus 4 factorial, which is 2 factorial. Okay. Now going to the next question. Question number 7 says, arrange 5 zeros and 5 ones in a row such that no 2 zeros and ones are together. Sir, this is kind of repeated question. We have seen this kind of question. This is same kind of this player, 5 boys and 5 girls. See, 5 zeros and 5 ones. So why to solve? We know straight away answer. The straight away answer is what? 2 cases would be generated and therefore 2 into 5 factorial the whole square, right? We know in the previous slide we have solved. Very good. This is wrong. Okay, this is wrong. Sir, why this is wrong? Since 5 O's are identical, but 5 boys are not identical. 5 boys were different, B1, B2, B3, B4, B5, right? So all the boys were different. So this kind of thing is right here. But here that failed because 5 O's 0, 0, 0, 0. We don't have 0, 1, 0, 2, 0, 3, right? So 5 O's are identical. Similarly, 5 1's are identical. Therefore, this is the wrong answer. Okay. Since 5 zeros and 5 ones are identical, therefore the cases which are possible where no two zeros and ones come together, which means alternate zeros and ones, one case can be this, starting with 1, then 0, 1, 0, 1, 0, 1, 0, 1, 0, right? So 5 pairs like this, yes. Or else you may say starting with 0, then 1, 0, 1, 0, 1, 0, 1, 0, 1, right? Like this 5 zeros and 5 ones can be arranged. Therefore the answer is 2. Answer is 2 and not this thing, 2 into 5 factorial the whole square. The reason being very simple. The reason being since we have identical stuffs. Otherwise, if they were not identical, let me say here it was boys or here it was girls, then this thing is absolutely true. Okay. But since they are identical, you have to be cautious. So finally, topic 1 is done. Now we can go to the second topic, circular arrangement. Circular arrangement means arranging the objects or person on the circular table. Like in the word problem, the keywords would be circular table or round table or necklace or garland. Like arrange stones in the necklace. Necklace is a circular stuff, so circular arrangement. Similarly, garland, flowers in the garland. So again a circular arrangement. Okay. These are the keywords which would be used to indirectly say that you have to use the concepts of circular arrangement and not the linear arrangement. Now, what is the difference between the linear arrangement and circular arrangement, and what is the formula? Okay, let us analyze and arrive at the answer. Suppose the question is arrange 3 boys in first is rows and second is circular table. Rows you know how to do, 3 boys, 3 vacancy in a line. So 3 factorial ways. 3 factorial is 6 ways. You can see these are the 6 possible ways: b1, b2, b3, b1, b3, b2, so on and so forth. In the circular table, how they will sit? As you can see, b1, b2, b3, let me start with here. In the circular table, b1 is seated here, then b2 is seated here, and b3 is seated here. Okay, so this thing you can see b1, b2, b3. Now you might be thinking that this thing is a different stuff in circular table, but no, this thing is actually same as this arrangement. Similarly, you can say this thing is same as this arrangement. Now your question might be, how come? How come? This part is pretty much clear, b1, b2, b3, we can see b1, b2, b3, this part is pretty much clear, but how come this two is this thing only? Because listen carefully, critical line I'm going to speak. In a linear arrangement, rotation changes the position. How come? See, linear arrangement, start, end. If I do a rotation, start became the end, end became the start. So in linear arrangement, rotation changes the position. But in the circular arrangement, there is no start, there is no end. Can you see any start, end? No, there is no start, there is no end. So rotation does not change the position. Even if you do the anti-clockwise or you do the clockwise, rotation does not change the position. Why? Because there is no start, there is no end. If there is a start and end, then only rotation changes the position, like the linear arrangement, right? So you can see I can prove this and this are same. How come? Just do the rotation. If I rotate clockwise, then b1 comes down, b2 will come here, and b3 will come here, right? So can you see b3, b1, b2? So b3, b1, b2. So similarly, if you rotate one more time, you will get this thing as well. Okay, so now no hard and fast rule, like you did one time rotation, so b1 came here, b2 came here, b3 came here. Okay, so if you do one more rotation, b3 will come here, b1 will come here, b2 will come here. So see, b2, then b3 and b1. So b2, b3, b1. Understood? No issue. So this, so these 3 cases were making one case in circular permutation. I hope you got the idea. So in circular permutation, less cases would be there compared to the linear permutation. Now talking about the rest. What about the stuffs? What about this stuff? So you can say it as B1 seated here. Okay, now take B2 here and B3 here. Okay, so take B2 here, take B3 here. So if you do that, you will get your B1, B3, B2. So B1, B3, B2 you got. And similarly, if you do the rotations, you will get the rest player as well. Okay, B1 come here, B3 come here, and B2 come here. So your B2, B1, B3 arrangement, can you see? B2, B1, B3. So similarly, one more rotation will bring the last case as well. I hope you got the idea. So this 3 cases in linear arrangement became 1 case in the circular. So finally, you have seen in circular arrangement only 2 cases makes the answer. So number of ways of arranging 3 boys in circular table is 2. Number of ways to arrange 3 boys in a row is 6. Understanding? If understanding, then is there any generalized formula? Because doing this manually every time is a very tedious task. Do we have a generalized formula? Obviously. 3 boys on circular table, the answer was 2 ways only. So 2 ways can be written in this way, 3 factorial by 3. How come you are writing in this way? 3 factorial means the way you can do it linear ways. But we know in linear ways we have redundant data. Okay, so that redundant data we have to divide. So divide by 3. Why this 3? Why not 2, 4, 6 or 1? Because this 3 is nothing but number of members. 3 boys were there, number of members. So divide by 3. If you do this, you will get your 3 boys arrangement on circular table. Very simple. So if I generalize, n boys on circular table, n factorial by n. So in general, circular arrangement is n factorial by n. And n factorial by n, since some books will say that n factorial by n, we can open the factorial in this way, n into n minus 1 factorial. So n cancel, the answer is n minus 1 factorial. So yes, number of ways in circular arrangement is n minus 1 factorial also. But I hope you got the idea why it is less compared to the linear arrangement. So linear arrangement, you can see it was n factorial, whereas circular arrangement it is n factorial by n, which is n minus 1 factorial. So finally, I hope you got the complete idea on linear arrangement versus circular arrangement. Now let us go to the next slides and get some more concepts. Like this thing, steps to solve circular questions will be explained while solving the question. Otherwise, you won't get the idea what is going on and you would be confused, right? So just skip for now. I will come to this while solving the question. But this is very important slide, that the another way to look at the concept of circular arrangement. One way you know very well, from linear to circular you have seen, but there is one more way, this way. Same example, 3 boys, B1, B2, B3, I want to make them sit on the circular table. So how to do it? You know, answer is 3 factorial by 3, which is 2 ways. But this new concept says that first you fix one person, and the second step, the question automatically turns into the linear arrangement. Magic. See, first step is I will fix one person B1. Okay. Then I have 2 boys and 2 vacancy. Question turned into the linear arrangement, 2 boys, 2 vacancy, 2 factorial ways. That is the final answer of this circular arrangement question. See, so this is a new way to look at the concept. First fix one person on the table, and once you fix the person, start is fixed. See, in the circle we do not have the start and end. That was the issue. So you give a start to the circle, that this is the start, fix. Then once you give the start, then it is no more a circular question, it became the linear arrangement question. So question turns into the linear arrangement, and that is the logic actually, that circle has no start, you gave him a start, and once you gave him a start, the circle property is gone, it became the linear arrangement question. And then you said 2 boys, 2 vacancy, 2 factorial ways, that is your final answer. Okay, so this is one way to solve the question, and this is the other way which you have seen, n factorial by n. I will solve the question by both the ways. So the first question in front of your screen, arrange 6 boys and 5 girls in a round table such that all boys are together. This is a good question. Try this by yourself, then look at my solution. So first way is this way, the visualize way, that give a start to the circle and then it becomes the linear arrangement question, right? So this is my method 1. Let me draw a circle first. circle. Okay, then they are saying the constraint is all boys are together, so 6 boys should be always together. Treat them as one entity, so this is 1 player, and then we have 5 girls, 5 players, so total 1 plus 5, 6 players we have. Since we have 6 players, we'll fix 1 player. Let me fix 1 player. So who is that player you are going to fix, sir? I'm going to fix this boys, B1 2 3 4 5 6. Okay, so the 6 boys, treating them as 1 player, I'm going to fix them. Then the girls can sit anywhere, 1 2 3 4 5 here, anywhere they can sit. So tell me, since I'm fixing the boys, once you fix 1 player, then the question turns into the linear arrangement. So tell me, if the question has turned into the linear arrangement, then what is the answer? These girls have 5 vacancy and they are 5 girls. So as per linear arrangement, girls can be seated in 5 factorial ways. But that is not the final answer. The final answer is girls and 6 boys inside this box can also be seated as per linear arrangement. As per linear arrangement, this 6 boys inside this box can be seated in 6 factorial ways. So multiply that and you will get the final answer. Isn't it easy? Circular arrangement turned into linear arrangement just by one trick, giving circle a start. I gave circle a start by fixing this 1 player. And then the question is automatically linear arrangement. 5 girls, 5 factorial ways, box has 6 boys, so 6 factorial ways, multiply them, get the answer. Very much linear arrangement concept, right? Now comes the second way, which is my favorite. Yes, this is my favorite, okay, because there is no need to make any table and any kind of stuff. Straight away we get the answer. So how to solve this using the method 2? So to solve this using the method 2, what I do generally is 6 boys and 5 girls in a round table such that all boys are together. So all boys together means 6 boys should be treated as one entity, and then we have 5 girls. So girl 1 2 3 4 5. Okay, so 5 girls. So what I do is, first step of this method is use one time circular arrangement concept, which is n factorial by n, one time. Then solve like linear arrangement. That's all. So what I'm going to say is, these players are going to sit on the circular table by 1 2 3 4 5 6. 6 players are there, right? So 6 players on circular table can be seated in 6 factorial by 6 ways. Okay, this is my one time circular arrangement concept done. Okay, so one time circular arrangement concept done. And also we know that in this box we have 6 boys. So 6 boys can be arranged among themselves in 6 factorial ways as per the linear arrangement style. Okay, and that is the final answer. So 6 factorial by 6 is nothing but 6 into 5 factorial by 6, which is 5 factorial, and into we have 6 factorial. Understood? So this is how we solve the question using the method 2. What we do is, one time we use the circular and then no more circular, then always linear style. Okay, so we have seen that we had 1 player, 2 3 4 5 6, 6 players seated in 6 factorial by 6 in the circular style, one time done. Now whatever is there you do by the linear arrangement, like the 6 boys can be seated in 6 factorial ways. Whereas this method 1 was fix 1 player, then the question turned into linear arrangement. So fix this boy, linear arrangement, done. Okay, but I told you method 2 is my favorite because it is time saving. No need to create the round table, just follow this 2 step always to get the answer. You don't believe me? Try this question by yourself. Arrange 6 boys and 5 girls in a round table such that all girls are together. Pause the video, try by yourself, then look at my solution. Whichever way you feel comfortable, you can do it. My way is all girls are together, so 5 girls should be together, so make them 1 player. Then we have 6 boys, they are not like inside a box. Okay, 6 boys are like this, B1 B2 B3 B4 B5 B6, like this. So how many players are there? 6 boys, right? So 6 boys and this box. So 7 players are there. 7 players can be arranged in 7 factorial by 7 in the circular concept style. So only one time you have to do, and then always use the linear. So 5 girls can be seated among themselves in 5 factorial ways. Final answer is 6 factorial into 5 factorial. Easy, isn't it so? If easy, try this question by yourself. Arrange 6 boys and 5 girls in a round table such that all boys and girls are together. Okay, all boys and girls are together. See, no need to make any diagrams and all these things. All boys together, so 6 boys inside a box. All girls together, 5 girls inside a box. Treat them as one player, right? So 2 players can be arranged among themselves in 2 factorial by 2 because one time circular, and then use the linear arrangement concept. 6 boys 6 factorial and 5 girls 5 factorial. Okay, so linear arrangement style. So if you solve this, 2 factorial by 2 is 1 and final answer is 6 factorial into 5 factorial. Understood? If understood, try this question. Arrange 6 boys and 5 girls in a round table such that no girls are together. No girls are together. So what is the answer? No girls are together. Now this seems analytical. Here we have to make some pattern. So yes, you can make the pattern as per your linear arrangement style. I have no issue, and then you can use your steps to get the answer. Like 6 boys and 5 girls in a round table such that no girls come together. No girls come together means boys should be seated first. So when boys sit in the linear arrangement style, we know it very well, behind, forward, then no boy should be there, right? Dash means these are the position for the girls, right? So B dash, B dash, B dash. How many boys are there? 6. So 5 is done and this is 6, right? So you might be thinking, oh, now we know very well, sir. The answer is, for the boys, the arrangement is 1, 2, 3, 4, 5, 6, right? 6 factorial by 6 because circular, right? And then we can go to the linear arrangement style. So the linear arrangement style is, how many vacancies for girls? 1, 2, 3, 4, 5, 6, 7. 7 vacancies, but 5 girls only. For girls, 7 vacancy, but 5 girls only, so 7p5. So the answer is 6 factorial by 6 into 7p5. Yes, very good. That is the incorrect answer. Sir, what is incorrect? You only told me that one time circular and then rest time linear. That's all what we have done. Yes, I agreed. That's all what you have done. But you have missed one thing. In the round table, what happens is your this dash and this dash is same. Just do the round. Okay, just make it circle. Just join it. Just make it a circle. You will see that this and this is same because there is no start and there is no end in the round, right? So actually they are same. So there is only one vacancy. Okay, either you consider this or this because they are same. So if that is the case, then what is the answer? Okay, so boys stuff is good. This thing is actually was a mistake. Okay, so the actual answer is how many vacancies? 6 vacancies. See, 1, 2, 3, 4, 5, 6. Okay, because this last and this are the same, so consider only one time. Okay, so 6 vacancies only there, and 6 vacancies there. Out of 6 vacancies, 5 girls arrangement 6p5. So 6p5. This is the final answer. So if you simplify this, you will get 5 factorial into 7p5. I know how you can simplify. So I won't go to the sorry, not 7p5. It is 6p5. So you know very well how to do it. 6p5 is nothing but 6 factorial. So that is the final answer. I hope you got the idea how to solve this kind of question. So remember that it is same not in the linear but same in circular arrangement. Okay, so I hope you got the idea. That's it is same, first and the last blank is same in the circular arrangement. So very important, very critical to note while doing the revision. Okay, so you can start with the linear arrangement pattern and you can use the circular arrangement concept to arrive at the answer, but you have to be very specific what you are doing. If you do not know what you are doing, you may arrive at the wrong answers. Going to the question 5, arrange 6 boys and 5 girls in a round table such that no boys are together. Now you know very well. No boys are together, start with the girl. So girl dash girl dash girl dash girl dash girl dash, right? So sir, why not a dash here? Because redundant, this dash is same in the round table, so only make one dash, right? Why to make two? So you know very well this is the right pattern. If this is the right pattern, now tell me that 5 girls, right? 5 girls and this thing. So arrangement, you will say girls arrangement is 5 factorial by 5 because circular kind of fashion. And then boys, we have 1 2 3 4 5 5 position and 6 boys, so we can use 6p5. Yes, very good. That is your final answer, which is wrong. Sir, now why this is wrong? Because everything we have done, there is no issue in dash. See, the dashes you said in the previous we made this mistake, right? The mistake was made here. The mistake was made here, right? In the dashes. So now we have overcome that issue. We know that the dashes is not the problem. Then what is the problem? Problem is this thing, 6p5. Okay, sir, how come it is a problem? You do a self-analysis, you will get the idea. Okay. You do a self-analysis, you will get the idea that everything is right, the pattern is right, this thing is wrong. Okay, this thing is wrong because 6p5, 6 factorial is not the answer. You try it manually. Take one example. 6 boys you have to fit. So boy 1, boy 2, boy 3, boy 4, boy 5, and 1 boy is left. You will say, sir, 1 boy can come here. No, this dash is same, so no one can sit here because the player who is sitting here is actually this player only. Okay, then sir, that 1 boy is left. What to do for that boy? He will come here only, there is no choice. So no 2 boys together can never happen, in this scenario. Okay, so actually it is 5p6, which is not possible. Okay, mathematically this is not possible, and example wise also I have told you that 1 extra boy is there, and therefore since we have 1 2 3 4 5 dashes, but we have 6 boys, so 1 extra boy is there. 1 extra boy will sit beside a boy only. Okay, he cannot sit beside a girl. Okay, and make that partition. Therefore answer is 0. The arrangement such that 6 boys and 5 girls are seated on the round table where no 2 boys are together cannot be made. Such arrangement is 0. Reason is 2 boys will come together in every case. Yes, in every case they will come together. Okay, so that is the answer. 2 boys will come together in every case. You can make by yourself also, I have told you. Coming to the next question, arrange 5 boys and 5 girls in a round table such that no 2 boys and no 2 girls are together. Okay, no 2 boys, no 2 girls are together. So here there won't be any issue. So let me show you. Boy dash boy dash boy dash boy dash boy dash, right? So you can see that here I have 5 boys, 1 2 3 4 5, and 5 dashes, 5 boys and 5 dashes. So alternate I have to make, otherwise you will say that if you do not make alternates, then boys came together or girls came together. But if I have alternates, then no 2 boys can come together and no 2 girls can come together. So boys arrangement I can make it as 5 factorial by 5, 1 time circular, and then the question is linear. So 1 2 3 4 5, 5 vacancy, 5 girls, linear arrangement 5 factorial. So the answer is 4 factorial into 5 factorial. This is 4 factorial, this is 5 factorial, right? Now some student will have doubts, sir, why you started with the boys? You can also start with the girls, right? You can say girl dash girl dash girl dash girl dash girl dash, right? In this way, so it should be 2 times of this thing. Are you sure this is what you want to make me debate on? Circular, not linear. So circular, just shift, girl will come top, shift, boy will come top, shift, girl, because there is no start and no end. So this start end do not play in the circular. Okay, that start with boy, start with girl. Okay, so don't play with that. So I will write it here. Since circular arrangement, therefore boy start or girl start is same only since no start point in circle in circle, right? If you are seeing that my circle is like this, boy started, if I just, and girl here and girl here, right? So if I just rotate, then girl will come at top. Okay, so since there is no start point and no end point in a circle, okay, so boy start, girl start, that concept doesn't come in this circular arrangement. Whereas if it was a linear arrangement, you know very well what you have done in the linear arrangement. Let me go back and tell you. I guess this is the thing you did, right? So this is the thing, because boy start, girl start made different cases here, but in this thing boy start, girl start doesn't make cases here, since circle has no start point. Okay, going to the next question. Arrange 6 boys and 4 girls in a round table such that G1 and G2 girls are always together. So easy question, not that tough. Pause the video, try by yourself, then look at my solution. Arrange 6 boys and 4 girls in a round table such that G1, G2 girls together. So G1 and G2, okay, let me write in this way. G1 and G2 are one box, one player. Then we have G3, G4, since we had 4 girls in total. And then we have 6 boys, right? So we can see how many players? 6, 7, 8, and 9. 9 players can be seated in a round table in 9 factorial by 9 ways. And then this can be seated in 2 factorial ways since linear arrangement after that. Okay, easy. Coming to the question number 8. Arrange 3 flowers ABC on garland. Sir, very easy. Garland is a circle. A garland is a circle, so I am going to say that circular arrangement, and in circular arrangement 3 players on the circular table is 3 factorial by 3, which is 2 factorial, which is 2 ways, right? This is how, like same question, right? 3 boys on a circular table, 3 factorial by 3, same kind of stuff. Very good. This is the wrong answer. Sir, why every time we do correctly but we get the wrong answer? Because it's a garland. In garland, your viewpoint changes. Check it out. Okay, this is my first circle. This is my second circle. Okay, here I have ABC. Okay, and here I have ABC. As per the circular arrangement style, these two are different, right? Because here the collection happens of ABC and here the collection happens of ACB, right? So these two are different as per the circular arrangement concept. As we have seen also in the first slide itself, circular arrangement, right? We have B1, B2, B3 and B1, B3, B2. These two are different cases, and yes, it definitely makes sense. Okay. But in the garland, these two are same. Okay, what? Yes, in a garland, in a necklace, these two are not different. Where in garland or necklace? Now your question might be, why so? So it's very simple, just visualize with me. Take a garland, mark flower A, B, C. See from my side, like the back side of the garland, see it and collect the flower in the clockwise. You will say, oh, it is ABC. So this is how the collection would look like this. ABC, isn't it so? This figure you are going to see, right? Collection in the clockwise. So ABC, this figure you are going to see. Now same garland, see from the front side. Notation, remember, A, B, C. See from the front side and collect the flowers in the clockwise. You will say, so ACB collection will happen, which means this thing, ACB collection will happen. Isn't it so? Take coin, mark and do it by yourself. Then only you will get the great clarity that from the back side you are getting ABC, from the front side you are getting ACB, but this ABC and ACB are not two different garland. It is the same garland. Oh, same garland. Same garland. Back view, front view of a same garland. Yes, therefore I told ABC and ACB are not different in garland or necklace. Reason was very simple. Reason was you had two view, back view and front view. Then sir, in this circular arrangement round table concept where you arrange the boys in this circular table, then why you told that there are two ways? Because here B1, B2, B3 and B1, B3, B2 are two different arrangement. Sir, how come here they are different? Because circular table has only one view. This is how your circular table looks like. In the hotels you go, you see a circular table, you see only one view. Okay, you never see from the bottom side and you say, oh, seat from left, seat from right. You never do that. Okay, you have only one view, that is the top view. Therefore, if you have only one view, this B1, B2, B3 and B1, B3, B2 were two different stuff. But garland has two views, back view and front view. Since it has back view and front view, therefore these two are not different. Always remember, these two are different in only one view, that is a round table arrangement, but these two are same in the garland because front view and back view. I hope now you got the great clarity on why they are same in the garland or necklace. Let me write it here, that the reason was if this is the back view as per my example, then this is the front view, right? But this back view and front view are of same garland only. Therefore, for this example, the number of garlands possible for 3 flowers is 1. Yes, the number of garland possible for 3 flowers is 1. So this is the visual way, but if we have more such flowers, then how to solve? We can't do like this every time. Yes, there is a general way. In garland and necklace question, since anti-clockwise and clockwise case is same, which means if you see like this, ABC, and this was like anti-clockwise. See, this is a clockwise arrangement ABC, right? And we switch players B to left and C to right, so it became like ABC, right? If you just focus on the players, ABC players, this is how the clockwise looks like, and this is how the anti-clockwise looks like. Right? Clockwise and anti-clockwise. So what I'm writing here is, in garland and necklace question, anti-clockwise and clockwise same is actually same. Reason being, front view and back view of the same garland you are looking. Therefore, the circular arrangement is now n factorial by n, but also you are dividing by that 2, just to avoid that anti-clockwise and clockwise scenarios, which you generally consider as different in general. But in this case, you are dividing it by 2 and saying we are only considering one case. Okay, where this case you generally consider 2, but by dividing it by 2, you will say I'm treating them as the one case only. Okay, so this is how we are doing. So same formula, n factorial by n, just you are doing a divide by 2 to avoid the repetition. Okay, I hope you got this idea. If you got this idea, try this question. Arrange 8 distinct stones on necklace. You know very well necklace question, so repetition you have to avoid, that extra 2 will come in the denomination. So 8 distinct stones, circular arrangement, 8 factorial by 8, but remember that 2, why this 2 is there in this denomination, since avoid repetition of, just to avoid repetition. I hope this keyword is pretty much clear, right? So that is the answer. 8 factorial by 2 into 8, which is nothing but 7 factorial by 2. Okay, you can write it in this way. This is 7 factorial by 2. Final question of the day. Arrange 4 identical red flowers, 3 identical blue flowers, 6 identical yellow flowers on garland. A lot of students will say, sir, now I am mastered in this topic, right? So it's very simple. That how many players we have? 6, 4, 10, 13, right? Circular arrangement, so 13 factorial by 13. But since it is a garland question, so repetition we have to avoid, so divide by 2. Very good, this is the wrong answer. Sir, every time I make blunders, why? Because identicals, you remember permutation concept, whenever identical happens, that same kind you have to again divide. Remember the letter sister, if you arrange among themselves, then it is 1, 2, 3, 4, 5, 6, 6 factorial divided by s is repeated 2 times, so 2 factorial. That division you have done when identical stuffs are there. Sir, I forgot. You have to not forget in the exam. That's what I was talking. So 13 factorial by 13. 2 will come to avoid the repetition. 2 will come to avoid the repetition. And then you have to also make 4 factorial, 3 factorial, 6 factorial. This is for the, let me write it here. This is because identicals are there. Okay, identicals are there. So that is the final answer. What is the final answer? 13 factorial by 2 into 13 into 4 factorial into 3 factorial into 6 factorial. That is the final answer. I hope you now understood each and every concept. Let me give a quick recap on the circular arrangement. Circular arrangement, we have seen 2 style. So from linear arrangement to circular arrangement we have seen. This is how the 2 cases were there, and redundancy you can make sure that n factorial by n you do, and these were the 2 steps which we have used for almost all the questions. Then another way to look at the concept, first fix one player, then question turns into the linear arrangement, right? And this is how we have solved the first question by both the method. Then we have seen that time saving is there in the method too, because no need to create the round table. So just you can see here, no need to create the round table, get the answer. But when the patterns are there, make sure that in the linear style if you are writing, so the first and the last blank is same in the circular, so keep an eye on that. And also keep eye that if this stuff happens, that we have 1 2 3 4 5 vacancies and 6 boys, and the constraint is no boys are together, then be cautious. It should not be like you are saying 6p5 is the answer, because n should be greater than r. It should be 5p6. Example wise, it's not possible to make that arrangement, because 2 boys will always come together in this case. So it's a very good question. Let me give a star mark. So star marks are the question where a lot of students make mistakes. So this thing you have seen. Then also this is also star, arrange 5 boys and 5 girls in the round table such that no 2 boys 2 girls are together. You might say 2 times of this thing, which is wrong, because no start is there in the circle. So do not say B started or G started, right? Then we have seen this thing which was easy. We have seen garland, which is a good question. You said 2 ways, but you forgot that garland has 2 views. Because it had 2 views, then front view and back view will give this scenarios anti-clockwise, clockwise. So consider them only one time, because this is the view of the same garland, right? So consider them one time. How to do that mathematically? Divide by 2. That's all. So in the questions we divided by 2 to get the answer. And if identical comes, then make sure you are making that division as well. So yes, that's it for today. I hope now you are mastered in this arrangement class. Thank you for watching this class. In today's class, we are going to solve gate questions on permutations. First of all, I will give you all the questions so that you can try by yourself. Then you look at my solutions with tricks and techniques, and also I will explain the traps. So let us start the lecture with the very first question. You have GATE CS 2001. Pause the video, try by yourself, then go to the next question. Question number 2. It's a word problem. Very good question. Next question is again a word problem. I will say it as a level 2 question, not level 3. Then which is level 3 question, sir? This is a level 3 question. Question number 4. This is again level 1, level 2 as per your convenience. Next question and the final question of the day, it's an easy question, level 1 question. Okay, so now let us look at the solution. I hope you have tried all the questions by yourself, then only looking at the solution makes sense. Otherwise, what's the point, right? Okay, question number 1 in front of the screen. How many 4-digit even numbers have all 4-digit distinct? A, B, C or D? GATE CS 2001. So pause the video, try, look at my solution. The correct answer is option B. 2 key things you have to understand. First, 4 distinct digits, which means repetition not allowed. Second thing, no direct formula is there. Permutation, combination, no direct formula. In the counting principle, I have explained how to count and get the answer. Also in the permutation class, I have explained how to deal with this kind of questions, right? Going from left to right, right to left, what are the traps, everything is explained in detail. So all those concepts will be useful in solving this question. So first watch my conceptual lectures, then only come to the GATE PYQ lecture. Otherwise you won't be able to connect. Now coming to the solution, First point, given data we have to write 4-digit even numbers are there, distinct is the possibility. Now since 4-digit numbers are there, what are the single digits we have? From 0 to 9 we have 10 such digit, but we cannot place randomly and say we can say 10 into 9 into 8 into 7 and that's how your answer is, final answer comes out. That is not correct. Constraints we have, as per the constraints we have to do the filling. Constraint number 1, last digit should be even, then only the complete 4-digit number would be 4-digit even number, right? So last digit should be compulsory even. What are the possibilities? 0 can come or 2 can come, 4, 6, 8, these are the possibility, right? Now the problem is with the 0, because 0 can overlap, right? 0 can come here or come here or come here but cannot come here. Why? Because if 0 comes here, then it is no more 3-digit or 4-digit number, it becomes a 3-digit number, right? We are in a search of 4-digit number, hence 0 cannot take this place. Then how to fill? A lot of students, what they do is they say, sir, if you want to solve this kind of problem with the constraints, make cases and solve. Which kind of cases? Sir, fix the position 0 and solve. In the class we have done similar kind of stuff. So yes, make cases and solve. Please make a note, 0 is present, so be aware what would be the cases. 0 at the last, 0 at the second last, 0 at the third last. 0 cannot come at the fourth last because then it will become the 3-digit, but we do not need that, we need 4-digit number, right? So a lot of students just leave at the 3 cases only, which means we have only 3 cases. No, 0 can go outside also, which means 0 is not present in your 4-digit number. So that case also you have to consider a 4-digit number where 0 is not allowed. Okay, so these are the 4 cases. If you fill that correctly, you will get your answer. Starting with the first case where 0 is at the last, it is fixed. Now we have 3 dashes and the possibilities are 10 digits are there from 0 to 9, 10 digits, 1 is gone, so 9 is left. Anyone can come here, right? So 9 possibility. Once it is done, then it cannot go further. So for the next dash, we have 8 possibility. Once it come here, it cannot go further. So out of 9, 2 is gone, so only 7 is left. So the numbers where 0 is at the last and 4-digit number would be created, which is a 4-digit even number from this scenario is 9 into 8 into 7, which is 504. Is it clear? Very simple, right? Going to the second case, which is more critical, because now 0 is taking this position and you cannot say 987. Why, sir, you cannot say 987? Because we need 4-digit even number. Because of that even, last digit should be filled first. 2, 4, 6, 8, these are the only 4 even number possible. Why not 5? Previously you said 5 digits are there for the even. Because 0 is already fixed. Therefore only 4 even digits are left. So 4 possibility for this. Okay. So now you can see we have only this 2 dash where 10 digits are not left. 1 is gone here, 1 is gone here. So 8 digits are left. So this blank get the 8 possibility. And once it's done, then the next will get the 7 possibility. So the final answer for this case is 8 into 7 into 4, which is 2 to 4. Understood. Going to the third case where 0 takes the third last position. Again, same scenario, last should be even, so 4 possibility. Then out of 10, 2 digits are gone. So for the first blank, only 8 possibility. Then for this remaining last blank, it would be 7 possibility. So 8 into 7 into 4, that would be 2 to 4. Coming to the final, which is very good example, where 0 is gone. So out of 10, you have 9 digits left. So a lot of student thinks 9 into 8 into 7 into 6 would be the answer. Wrong. Even a 4-digit number you need. Therefore, last blank should be filled first. So for last, we have 2, 4, 6, 8, 4 possibilities. So 4. Once it's done, now you have to start from left to right. Now you have to say out of 10 digit, 0 is gone and last blank 1 digit is gone. So out of 10, 8 is left. So for the first blank, 8 possibilities, second would be 7, third would be 6, 8 into 7 into 6 into 4, because this is also having 4 possibilities, right? So the final answer is 1344. Add them all, you will get 2296, and that is the correct answer, which is option B. Now this is method 1. Fixing zeros like this to get the answer. There is also method 2. As explained in class, there are various ways to solve this kind of problem. Some students might think in this way, 0 I fixed at the last, and if I do that, the case 1 which I explained here, same to same replicates, and 504 possibilities are there. But for the case 2, 3, 4, we can combine them and we can make it 1. How can you do that, sir? 2, 3, 4, combine them and make it into 1. See, like this. I will say dash 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 dash, okay. Last should be even. Since here even last was not present, so this case was such where 0 is at the last. Next case I am taking such where 0 is not at the last, but even numbers can have the last position. So 2, 4, 6, 8 can take that position, which means 4 possibility. Now coming to this blank, we have to go from left to right to avoid any miscalculation. You know, if I go from right to left, miscalculation happens, explained in the class already. So always go from left to right when 0 is present. So we'll start with the first blank and we'll say that 0 cannot come here since we need 4-digit number. Also the number at the unit place which is gone cannot repeat here. So for the first blank, 2 numbers are gone. Out of 10, when 2 is gone, 8 is only left. So 8 possibility. For the next, it won't be 7. Sir, why it won't be 7? Because 0 can come here. Okay, 0 can come here. So now see carefully. 1 digit gone here. For this blank, I am explaining why it is 8. 1 digit gone here. 1 digit gone here. So out of 10 digit, 2 is only gone. So 8 is left. So here we have 8 possibility. Understood? Then what about this blank? Will it be 8, 7, 6? What it would be? See, 1 is gone here. 1 is gone here. And 1 is gone here. 0 can be possible. So out of 10, 3 is gone, 7 is only left. So 7 possibility. Understood? If understood, then I guess this case is pretty much clear, which contains all these 3 possibilities in just one scenario. So 8 into 8 into 7 into 4 would be 1792. Add them all, you will get 2296. Understood? So there are 2 ways to solve this kind of question. This is a very critical way to think. If you can think it wisely in the GATE exam, then go for it. Otherwise, this is a very layman technique to solve the question. Okay, but confidently you can comment on the answer. Coming to the question number 2. N couples are invited to a party with condition that every husband should be accompanied by his wife. However, a wife need not be accompanied by her husband. Okay, the number of, I won't comment anything, otherwise feminism, feminazist will comment on the video. So I will refrain from doing any comment. The number of different gathering possible at the party is what? A, B, C or D. It was asked in GATE CS 2003. Pause the video, try, look at my solution. Then the answer is option B. Why? Constraint is very important. See, we have n couples. Okay, we have n couples. First couple, second couple, third couple, fourth couple, till n couple. How many choices they are getting? That's what will decide the answer. Okay. Now, for the choices, the constraint is n couples are invited to a party with condition that every husband should be accompanied by his wife. So, if I make a couple husband comma wife, so which case is possible? Here, every husband should be accompanied by his wife. If husband is coming, then he should be accompanied by his wife, then only a valid case. What if husband is coming and wife is not coming? Then he is not allowed, not a valid case. That's what this line says. But coming to the wife first scenario, a wife need not be accompanied by her husband. She can come alone or she can come with the husband. Okay, so there is no constraint on the wife. So if wife comes and husband does not come, it's okay. If wife is not coming, husband not coming, that is also okay, because nothing is mentioned when husband does not come, what happens, when wife does not come, what happens, right? The constraint only is when husband comes, wife is compulsory. So husband comes, wife is compulsory. Husband comes, wife is not coming, not a valid case. And then when wife comes, then husband may or may not come. So when wife comes, husband is not coming, valid case. When wife comes, husband comes, a valid case. But when both are not coming, when husband is not coming or wife is not coming, that thing is not mentioned, which means by default a valid case, right? So if this is the valid case scenario, these are the choices for the couples. The number of different gatherings possible at the party is, which means first couple get 3 choices, first, second, third, right? 3 choices. First couple got 3 choices. How is the 3 choices? Just to explain, husband, wife coming, good. Husband comes, wife does not come, not allowed, so not a choice. Husband is not coming, wife is coming, good. Both of them are not coming, that is also good. 3 choices. Second couple also got the same 3 choices. Third couple will get the same 3 choices. Nth couple will get the same 3 choices. So the final answer is 3 into 3 into 3 into 3. Why multiplication? Because all of the couples should come. First couple and second couple and third couple and up till nth couple. Everyone should come in the party. Since and is there, multiplication will happen. So 3 into 3 into 3 into 3 up till n times, it would be 3 to the power n. Okay, so the answer is option B. Understood? Let us go to the next question. Question number 3 in front of your screen. Remember that whenever word problems comes into picture, do not get afraid. A lot of GATE aspirants get afraid by seeing a very lengthy word problem. Reason being, there is no direct formula to get the answer. Indeed, but whenever word problem comes into the picture, decode that into simple maths, find a logic to get the answer. That's the process for every word problem. Same process I'm going to use for this question. The question says a pennant is a sequence of numbers, each number being 1 or 0. An n pennant is a sequence of numbers with sum equal to n. For example, 1, 1, 2 is a 4 pennant. As you can see that 1 and 2 are the only digits used while making a sequence as per the data 1. Only 1 or 2 can be used, other numbers cannot be used. And what is a n pennant sequence as per the question, where sum of the digit is coming equal to n. Yes, 1 plus 1 plus 2, sum of the digit is 4, right? So 4 pennant ordered set makes sense. The next thing, the set of all possible 1 pennant is this thing, which makes sense, sum of the digit is 1, right? The set of all possible 2 pennant is 2, 1, 1, which means this 2 ordered set is coming in 2 pennant criteria because sum of the digit is 2. This is also coming in the 2 pennant criteria because sum of the digit is 2, and they are making them into a set. That's all. Okay, so set of all possible 2 pennant is nothing but making the curly brackets, and that's it. Coming to the third point, where set of all 3 pennants is like this. And then you have to note that the pennant 1, 2 is not the same as the pennant 2, 1. See carefully. 2, 1 is not the same as 1, 2. This is what they are saying. If that is the scenario, the number of 10 pennants is dash. GATE CS 2014 set 1. Try this question by yourself, then look at my solution. I know a lot of students, they will say, sir, super easy question. I have analyzed the word problem. 1 pennant, 1 ordered pair, right? 2 pennant, 2 ordered pair. And then 3 pennant, we have 3 ordered pair. So 10 pennant, 10 ordered pair. Very good. That is the wrong answer. Use logic to get the answer. First of all, write down the criterias. What are the criterias? First of all, 1, 2 is not the same as 2, 1. This indicates order matters. And order matters means permutation question, not a combination question. Now, second thing, we have to use 1 or 2, this digit only. Okay, digit 1 or digit 2 only. And the requirement is we need a number of 10 pennants, which means ordered pair such that sum of the digit in that ordered pair is 10. So how many such ordered pairs you can generate? This is what the requirement is. You have to find the number of ordered pairs such that in each ordered pair sum of the digit is 10. Now, how to think on the logic? To think on the logic, I came to the given example that 1 pennant they made this ordered pair 1, makes sense. For 2 pennant they made this. For 3 pennants they made this. So basically, don't you feel this is kind of arrangement of digits 1 and 2 in such a way that the sum of those digit comes out to be 3 for this 3 pennant criteria, right? See, this is ordered pair which is made out of a digit sequence, which is 1s and 2s are used, where sum of the digit is coming out as 3, right? So basically this is arrangement of 1s and 2s in such a way that the sum of the digit is 3. Similarly, our requirement says that sum should be 10, which means all the arrangements of 1s and 2s such that sum of the digit comes out to be 10. That's all. This is what the logic says. Once you understood this logic, then we can make table and get the answer. Arrangement of 1s and 2s. So arrangement question, it's like the letter arrangement but repetition happens, so divide by that, right? So type 4 in the permutation what we have studied. So this is a type 4 question of permutation. Okay, but cases are not specified. I have to create the cases and then add up all the cases. Case 1, how you will create a sequence of 1s and 2s where the sum is 10. I can say all the digits are 1s, which means 10 times 1 is coming, 0 times 2 is coming. Then you can see like 1, 1, 1, 1, 1. If I have such 10 digits of 1, sum is 10, a valid case. So tell me the number of ordered pairs you can generate from this. It would be only one, since everything is 1, 1, 1. So only one case. If you want to go with the maths permutation type 4 formula, you will say 10 factorial, all the 1s are arranged among themselves in 10 factorial, divide by the repetition. 1 is repeating 10 times, so divide by 10 factorial. So this is 1, which logically also I told you that one case only will happen. Now coming to the second case. Second case, can I take 9 1s and then some x 2s to get my sum as 10? It won't happen. It won't happen, right? 9 1s will make it as summation 9 plus what you will do to make it 10 if 2s can be used only. It's not possible, right? So if it is not possible, that case won't come where 9 times 1 is coming. Okay, so we have to go to the next. So oops. Okay, so we have to go to the next case. What is the next case? 8 times 1 digits are coming, so summation is 8, right? 8 times if 1 digits are coming, then the summation is 8. Then 1 time you take a 2 digit number, so summation is 2. Overall the summation is 10. Yes, 8 times 1 digit will give you 8. 1 time 2 digit will give you 2, so 8 plus 2 will make it 10. Okay, so this is a valid thing. But since if I just make the scenario 1 2 3 4 5 6 7 8 and 2, tell me the number of ordered pairs which I can generate. You know that 2 can come here or come here or come here, so there are many such ordered pairs which I can generate. So manually if you go, it will take a lot of time. So how to do it mathematically? If this is what we have, can you represent this as letters? If we have 8 times A letter and 1 time B letter, the number of arrangements is what? Total letters are 9. So 8 plus 1, 9 letters can be arranged among themselves in 9 factorial ways. Divide by repetition part. So this 1s are coming 8 times in our alphabet way. A is coming 8 times. So if 8 times is coming, 8 factorial division. So the answer would be 9 factorial by 8 factorial, which is 9. Understood? Just giving you analogy in the way which we have studied with the alphabets. Kind of similar. If you treat 1s as A's and 2 as B, this is what your arrangement of alphabets looks like, right? Similarly, we have to go for the rest scenarios. Case number 3. If 7 1s are there, then no possibility to get sum as 10. If 6 1s are there, so 6 plus 4 is 10, so 4 can be gotten if you take 2 digits 2 times. So 6 1s and 2 times 2 digit, so total we have 8 numbers. 8 numbers can be arranged among themselves in 8 factorial ways. Divide by the repetition, 6 factorial, 2 factorial, simplification gives 28. I hope how to do simplification you know very well. If you do not know, just by case, 8 factorial by 6 factorial, 2 factorial can be said as 8 into 7 into 6 factorial divided by 6 factorial. 2 factorial is 2. 6 factorials are gone, 2 1s are, 2 4s are 8, 7 4s are 28. Easy. All this are explained in the class already, so I won't repeat again and again, just to give you the idea how to solve this kind of question. Next, if we have 5 1s, then 5 plus what will give you 10? 5 plus 5 will give you 10, but 5 cannot be generated with the even digits, right? So go to the next case. 4 1s, 4 plus 6, 10, 6 can be generated if you take 3 times 2s. So this is a valid case. How to get all the ordered pairs? 4 plus 7, 4 plus 3 is 7. So 7 such digits can be arranged among themselves in 7 factorial, divided by the repetitions, 4 factorial, 3 factorial, so 35. Similarly 2 4 is the case, so 2 plus 4, 6 digits, 6 factorial ways, divide by the repetition, 15 is the answer. And final case, 0 ones and all the 2s. Okay, so 8 2s if I take. Oops, this is a wrong case, because 8 times if 2 you have, it would be 16, not 10. So summation 10 if you need, it should be 5. Okay, so yes, 0 times 1 and 5 times 2 will give the summation as 10, which is basically this kind of ordered pair. Okay, and only one case we know that this is only one case. If you want to go mathematically, then you should say 5 numbers arranged among themselves in 5 factorial. Since they are in repetition 5 times, divide by 5 factorial. Still you are getting 1. Okay, so that's the last case. And if you add all the cases, case 1, 2, 3, 4, 5, 6, you will get the summation as 89. So 89 is the correct answer. So I will say this is a level 2 question, not that easy, not that tough. Okay, so a level 2 question, good question. Coming to question number 4, which is a level 3 question. Suppose we uniformly and randomly select a permutation from the 20 factorial, which is nothing but permutation of 1, 2, 3, 4 up till 20 digits, right? What is the probability that 2 appears at an earlier position than any other even number in the selected permutation, A, B, C or D? It was asked in GATE CS 2007. Pause the video, try, then look at my solution. The solution is option B. A lot of students will mark D, but D is wrong. The correct answer is option B. In a lot of books also D is given, which is wrong. Okay, correct answer is B. How come? Why come? Let us see. First of all, by looking at the question, you have realized that 20 factorial, if they are saying these are the digits and 20 factorial, which means digits are not repeated, no repetition, then only you can say that 20 dashes we have and 20 numbers arranged among themselves in 20 factorial, which is nothing but 20 into 19 into 18 into 17 into 16 into 15 dot 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 up till 1. That's how your 20 factorial comes. So it's without repetition. The criteria is 2 appears at an earlier position than any other even number in the selected permutation. You know what? A lot of students will follow the method 1, which is correct approach, and see the problem in method 1. So we know that probability is requirement by total. Total ways of arrangement is 20 factorial, which means repetition not allowed. In the requirement, 2 appears before any even number. So there are various such cases, such as case 1, 2 is taking the first position, then the 19 places are left and it can be taken by any 19 number. In that scenario, 2 will always appear before any even number. Makes sense. So 19 places, 19 number, 19 factorial ways. Coming to the second case, where 2 is taking this second position. So even number cannot come here. If even number came here, this criteria won't be satisfied. So even number should not come before. Then who will come before? Odd numbers only. So for this places, we have odd number. But in 1 to 20, how many odd numbers are there? You can do it manually and count, but if you know 10, it's well and good. Otherwise, you can say 1, 3, 5, 7, 9, and then 11, 13, 15, 17, 19. Okay, so total we have 10 odd numbers. If we have 10 odd numbers, then that first position will be taken by the odd number, so 10 possible ways. Then we have the remaining dashes, which are nothing but out of 20, 2 dashes are gone, so 18 dashes. And 18 dashes and 18 numbers. How come 18 numbers? Because one number is gone here, one number is taken here. So out of 20, 2 are gone, so 18 are left. 18 places, 18 number, 18 factorial. So the total numbers which will be generated from this is 10 into 18 factorial. This is what the total number will generate for the case 2. Similarly, case 3. Case 3 means 2 is taking the next position, which means the third position. Previous 2 should be filled by the odd. So first dash has 10 odd possibility, 1 is gone here, then the next will have 9 odd possibility. Then we'll say the numbers which are after 2, these are 17 places, and 17 places and 17 numbers will be filled by 17 factorial ways. So the final answer is 10 into 9 into 17 factorial. So this is our third case. Similarly, fourth case will be generated 10 into 9 into 8 into 16 factorial. Then fifth case, sixth case. How many such cases will be generated? See, how many such cases is a very good question, because 2 is taking first place, then second, then third, then fourth, then fifth. A lot of people are thinking it will take up till 20 such places. No, no, no. We have 10 set of even number as well, right? And 10 set of odd numbers. So 2 cannot take up till 20th position. Otherwise, the even numbers will go ahead of the 2. And we want no one is going ahead of 2, right? Everyone is after 2, and 2 is at the first position. 2 is always at the top, at the ahead position, right? Okay, so if you see carefully, then in the 20 dashes, the last scenario which I am generating is by saying the first 10 dashes are taken by the odd numbers. Okay, first 10 dashes are taken by the odd number, and the next 10 would be the all the even numbers only, right? In the last case, all even number, but we need 2 is before every even number. So 2 is taking the 11th place. 2 is at the 11th place. That is the only last case. After that, blunders will happen, unnecessary cases will happen. So 11th case, 11th place, and 11th case is the last. Okay, and this is how you have to generate one by one cases. So first place to first case, second place to second case, third place to third case, fourth place to fourth case, 11th place to and 11th case. Okay, so now you have to add all the cases to get your requirement. If you see the pattern, it would be easy for you. 19 factorial plus 10 into 18 factorial plus 10 into 9 into 17 factorial plus 10 into 9 into 8 into 16 factorial. Next would be what? 10 into 9 into 8 into 7 into 15 factorial. Next would be, yes, you are getting the idea now. This is how the pattern looks like. Okay, so 19 factorial, this thing you have seen, right? Then next would be 10 into 9 into 8 into 7 into 15 factorial. Next would be 6 into 14. Next would be 5 into 13. Next would be 4 into 12. So on and so forth. If you go, you will get your answer. Okay, so these are your 11 cases, 11 requirements. If I am adding, this is what I am getting. And finally, probability is requirement by total. Simplify and get the answer. I know 1 by 10 answer I got. It looks simple, but if you do in the GATE exam, it will take a lot of minutes to get the final answer. Indeed. So therefore, method 1 was problematic. So while solving the final thing was a problematic. Not the conceptual way. Conceptual way was easy. Solving the final thing is a problematic, and getting the answer as 1 by 10. If the options were such as we have solved, then well and good. So the problem was, since we got a very big kind of equation at the last, lot of people in the books also, they are marking none of this. But that is wrong. If you simplify, you will get 1 by 10. So is there any other way to get the answer? Indeed. You can use a very simple logic method too, a trick, a very simple logic. Since it is uniformly and randomly thing done, so uniform distribution equiprobable for the every digit. So they are asking probability that 2 appears at an earlier position than any other even number in the selected permutation. So how many even numbers in total we have? 2, 4, 6, 8. If you check it out, 10 even numbers we have. In that you need 2 appears at an earlier position than any other even. So that is the only one case. 2 before other is the only one case, like this 2, 4, 6, right? Only one case. So one case out of 10, so 1 by 10 is the answer, as simple as that. A very basic logic to get the answer. Okay. If you want, you can also do by the combination as well. But this is a very simple thing to get the answer. So I hope you got the idea. Going to the question number 5, 4 fair 6-sided dice are rolled. The probability that the sum of the result being 22 is x by 1296. The value of x is what? NAT question asked in GATE CS 2014 set 1. Pause the video, try, then look at my solution. So it's not that tough, since you know probability questions how I solve, requirement by total. So what is total? 4 fair 6-sided dice are rolled. So 6 to the power 4 is the total cases, right? And then they need the requirement as sum of the result being a 22. So first die outcome plus second die plus third die plus fourth die outcome results to 22. This is what they need. Okay, so what is the example which you can think? 6 plus 6 plus 6 plus 6 is 24, but they don't need that. So 6 plus 6 plus 6, 18 plus what? 18 plus 4 will lead to 22. So yes. So how many cases can be generated? You can do it manually. 4 can come here, 4 can come here, 4 can come here. In this way 4 cases are there. Or simply permutation, numbers arranged among themselves in 4 factorial ways, then repetition is 3 times 6, so 3 factorial. So 4 cases will be generated. The next case you can think of is 6 plus 6 is 12, and then I need 10 to make it 22, so 5, 5. Okay, so again if you use permutation, 4 factorial by 2 factorial, 2 factorial, 6 would be the outcome. If you do it manually, you might fail to get some cases, right? So permutation is the best way to avoid any confusion. Just do the arrangement. 4 factorial by 2 factorial 2 factorial comes out to be 6. So total requirement has 10 such possibility. So probability is requirement by total 10 by 6 to the power 4, which is 1296. Given thing was your probability comes out to be x by 1296. So if I do the comparison as per the given, probability comes out to be x by 1296, and I solved and I got 10 by 1296. So just compare the numerator, you will get x is 10. That is the answer. Easy, isn't it so? So two things were there, probability concept and the permutation concept to get the answer. To the next question and the final question. When 6 unbiased dice are rolled simultaneously, the probability of getting all distinct numbers 1, 2, 3, 4, 5, 6 is what? A, B, C or D. 𝐀𝐍𝐃𝐑𝐎 2024 set 2. So it's not that tough question. Again easy question. Probability is requirement by total. Total is what? 6 unbiased dice. So 6 to the power 6. Requirement is what? All the digits in your 6 dice throw, they are distinct. Okay, so number of outcomes would be, use the permutation, right? 6 dice, 6 numbers, number of outcomes would be 6 factorial. Simplify, you will get the answer as option A, like this. Okay, 6 dice thrown, 6 outcomes should be distinct. First get the 6 chances, second have the 5, 4, 3, 2, 1, right? Multiply them, you will get this many sets, right? So this many ways where distinct outcomes are there. So requirement by total, you can see that 3 2s are 6 and this is also 6. So basically 6 to the power 4 is left. One of the 6 can be used to cancel out here because they have the presence of 2. Just the simplification part, which I should not tell, but still if you want, this is what your things look like. We have 5 and 4 and 6, then we have 6 to the power 2, 6, 6, 6, 6, right? So 6 to the power 2s are gone. Then 2 3s are, this is 2s are, 2 1s are, 2 2s are. If you simplify this, you will get 5 by 3 2 4. That is the final answer. Easy, isn't it so? So this question was easy indeed. Then you have seen this question was also kind of moderate but easy only. This question was level 3 if you are going with the method 1. Otherwise method 2 makes it super easy, but then your concept should be strong. This is also a level 2 question where analysis is required. Indirectly arrangement of repeated letters is what they are checking. Okay, type 4 permutation concept. And then this is also a level 2 question where you have seen analysis is needed to get the answer. Otherwise it's like a choices and a boxes. First box get how many choices, second box get how many choices. It's like the counting principle which we have seen, right? Then this is also a level 2 kind of question. Analysis is needed, 0 positions fix and then get the cases, or simply use some critical analysis to arrive at the answer very fast. So that's it for today. I hope you enjoyed the class.